Well, hello and welcome to this live stream for July 7th, 2018. Tonight we're going to visit a lot of asteroids if we can. We've got a bunch of them, probably about, I'd say 500 in the sky right now, but we're only going to visit a few of the more bright ones. And along the way we're going to see some pretty cool things, so stick around and we'll see those. I'm hoping that we will be able to also capture some pretty cool objects along the way. I won't give it away yet, but perhaps we will see them. I'm looking forward to it. I hope you are too, and I will see you soon. Well, good evening, everybody. Welcome to the SkyTour LiveStream for this July 7th, 2018. You will hear the occasional explosions in the background because around here, people just never stop celebrating the 4th of July, it seems, and it goes on and on and on for hours. So, you'll hear them going on and on for hours in the background. But tonight I wanted to try something a little different. I wanted to actually take us down a path where we can actually check out some cool asteroids, and there are quite a number of asteroids out there to check out tonight, and we're going to do just that. So hi Ronald, hey weird guy, I see you guys here already, that's nice. I'm going to have some fun with everybody tonight, I hope. Right here in the center of this particular view, you can't really see it too well, but right in the, just to the left of center, you see that bright object right there? That's actually called 193 Ambrosia. That's actually a 15th magnitude asteroid in the constellation of Virgo. Now it's pretty low in the sky at the moment, but it looks pretty cool nevertheless, and he'll give you a little information about this particular asteroid. It's a main belt asteroid, so it's out between, Mars and Jupiter, and it's about, I'd say 2.6 astronomical units from the Sun, so 2.6 times the distance of the Earth to the Sun. Alright, and that's pretty neat because that makes its orbit, or its year, 4.2 of ours. So 4.2 years would have to elapse for that to circle the Sun one time. And it's a relatively small asteroid. Again, it's 15th magnitude, so it's a pretty cool object. It's not, the actual diameter is unknown. We don't really know, but we do know that it is a main belt asteroid, so that's pretty cool. And one thing I wanted to mention to you also is that when we look at these main belt asteroids, one of the really neat things about these asteroids that we see is that they are actually many times asteroids that could have been part of, or some of the asteroids that were dislodged from the main belt that might have actually caused the extinction of the dinosaurs. And we know that some of the asteroids there could have caused this. We know that because we backtracked and reverse engineered everything that we see there. Yeah, weird guy, there's no ridiculous questions, frankly, to be honest with you. Hey Brian, how you doing? Nice to see you here. Thanks for joining. So, as I said, right there just to the left of center, we have the asteroid 193 Ambrosia. Alright, and it's hopefully it's going to be a night of asteroids. Now, one of the things you might notice is to the right of Ambrosia, and just down a little bit, you see a smudge in the field. Well, that smudge happens to be the galaxy NGC 5134. And NGC 5134 is actually a galaxy that's, not, of course, very, very distant. It's 19 million light years further away than that asteroid. And that's pretty cool. And it's a spiral galaxy, and it's in Virgo. And it's about 2.7 by 1.5 arc minutes in length. So it's got a fairly good size to it. But it's actually going away from us at about 0.6% the speed of light. That's one of the interesting quirks that we've seen with faraway objects. They tend to be receding from us or heading away from us at higher red shifts, it's called, at higher speeds. And the red shift is the shift of the light toward the red end of the spectrum by something moving away from us. It's the Doppler effect. All right, and the Doppler effect works with sound, as you know. As something's coming toward us, the pitch would increase, and as it goes away, it goes. So you've heard that when a car goes by, okay, or a plane, okay. As the sound is heading away, the sound is lengthening in the period or in the interval that it takes for you to go, that it takes the sound to go from crest to crest in its wavelengths. Hey Daryl, how you doing? And I think that it's pretty self-explanatory to notice that if you had light, and with light, you would actually have a similar effect. You'd have a Doppler effect with light as well. All right, and instead of increasing in pitch, like sound would, you actually increase in frequency or energy, and it increases toward the blue end of the spectrum. So anything moving toward us is thus blue shifted. Anything moving away from us is shifted toward the red end of the spectrum, so it's red shifted. And that's what we see with these galaxies. So this galaxy has a recessional velocity, that is a velocity of it going away from us, of 1,756 kilometers per second. You know, now your weird guy saying travel in Alcubierre white spacecraft for 10 minutes. The bubble, in the bubble. How much time has passed outside the bubble? Well, that's a good question. It depends, what's going on. Now, you're thinking of it as a light speed travel craft, but it's not. It's actually folding space. So the time that it takes for it to go 4.3 light years might be 2 weeks, say, if they do it gradually. But if you're talking about a spacecraft that's folding space, you're actually talking about a spacecraft that isn't violating or isn't causing Lorentz contraction. That is to say, the time dilation effects. So you would have, if it went 2 weeks on the ship, it'd be 2 weeks on the Earth. All right. It's just that it would oddly be there in 2 weeks' time when it should be taking, say, 12,000 years. And you'd say, wow, that's pretty cool. But it's a warp drive. It's folding space. So in any case, so you wouldn't have a time dilation, an Einsteinian time dilation with an Alcubierre drive. And the Alcubierre drive wouldn't be the Alcubierre white drive, as you say, there, weird guy. It would actually be the Froning, F-R-O-N-I-N-G, look that one up, Froning Alcubierre drive. Because the Froning drive, that variation of the Alcubierre drive, is the coolest thing, because that will actually literally give you shields, just like in Star Trek, no lie. So when Kirk says shields, and Sulu says shields, everyone, and Scotty says I sir got the shields, you don't have to worry about that because they're automatic. The process by which the Froning Alcubierre drive actually warps space also induces these shields around the outside of the craft. Really cool. I think that is I think that's just, it's a really neat consequence of the Froning variation of the Alcubierre drive. And for those who don't understand the Alcubierre drive, Miguel Alcubierre in 1994, he postulated this potential drive where you could have a drive that could basically build a bubble around the spacecraft that would allow it to travel by folding space, essentially. And that's what is happening there. That's what's happening there. So for those just joining us, on the left of center, we actually see a bright spot, the brightest spot you can see there in the sky. That's actually an asteroid that we were just looking at a few minutes ago. And that asteroid is called 193 Ambrosia, and it takes 4.2 years for it to go around the sun, and it's actually a 2.6 astronomical unit distant asteroid out past Mars and ahead of Jupiter, just behind, just not quite to Jupiter. So that's what's really cool, and let's go and see if we can find another one to go to. And as I said before, just to its right and down a little bit, you can see a little fuzzy spot. That fuzzy kind of line, it goes from the lower, a little bit, the fuzzy spot is sort of on a diagonal there, a tiny little diagonal, about 8 times the length of that asteroid that you see. Then the center, just left the center. And that galaxy is actually NGC 5134. So the asteroids are all throughout the sky. And we see them here everywhere. So let's actually take a look at another potential one. Let's see if we can find one that's more near a star that we might be able to recognize. Okay, here's one. We're going to go to this asteroid now. So it's actually going to be a slight movement. Alright, and let's get the camera active. Alright, and you won't see anything right here yet. Actually, you do. And that thing you see, the only thing you can see right now in the field of view, is actually, it's a star. Alright, and you see that star, I think that's the star just to the right. It's a little bit yellow. And let me see if I can identify the star, see if it's in our catalog here. Yes. That star that you see right there in the center, just about right in the center, is called HD 115947. But you can't see is the little asteroid that should be next to it. So I'm going to take an exposure, and let's do just a 10-second exposure at 12,800 ISO. And I'm really low to the horizon right now, so it may or may not come in. Let's find out. So let's see what we get. Maybe. Let's go back and look. Ah, yes. And now, okay, so that if you look right in the just right of center, that's the star HD 115947. And then to the upper left of it, you see another bright spot. Okay, and it's pretty much under the 2018 down a little bit. You see the second, pretty much the second brightest star-looking object. That's actually 54 Alexandra, the asteroid 54 Alexandra, and it's a asteroid that is again in our asteroid belt, our main belt, and it's 12th magnitude right now, and it's in the constellation Hydra. It's a little further than the last asteroid we just looked at, and it's in the constellation, like I said, Hydra. Its distance right now is 2.7 astronomical units from the sun. Now, you know, all the asteroids are going to be about that far away. Okay, some a little further, some slightly closer, about 2.2 AU at the most. And that's because these guys are all at the same distance, roughly, because the asteroid belt is at that type of distance from our sun. Okay, so that said, we see this asteroid out there, and it takes about 4.5 years to go around the sun, and it's a fairly large object. It's actually 166 kilometers in diameter, so that's not bad at all. So again, we have the star that we're looking at there, just to the right of center, and that star is HD 11. Let me go read this back again. HD 115947. Yes, David, this is live. And so now, when we look at that star, we look to the diagonally to the upper left. There's a bright star that's kind of below the 2018 that we just talked about, and that bright starry-looking object, that is the asteroid 54 Alexandra, 2.7 astronomical units from the Sun. Now, here's the beautiful thing: if we come back and take photos of these asteroid fields at a later time, we will see indeed that they have moved. And I think that's really the coolest part and the coolest thing that we can do here. And we may be doing that. We might have some time to do that. So, that said, let me go see if we can move us to yet another location. 1 second here. Alright, let's try this. Alright. Now, I don't know how loud the music is to you guys. I don't know if you can even hear the music. I hear the music loudly in my headset. So it's a little bit too loud for me, so I had to turn down the music. And I could turn it up out to you. But let me know what you think of that, if the music is the right volume and blend. Okay, meanwhile I'm going to search for yet another asteroid. Yeah, I love these things. These are so cool. Now, if you're listening to SkyTour Radio at all, you know we've been talking about asteroids quite a bit. And I would say that, you know, the asteroid belt, if you look at the total mass of every asteroid in the belt, first of all, you notice that the biggest asteroids, which is, first of all, Ceres, C-E-R-E-S, Ceres is the largest, and then Vesta, the next largest. Ceres and Vesta make up the majority of the mass of the asteroid belt, believe it or not. They're about a third of the overall mass of the entire belt. Not only that, the overall asteroid belt really is only about less than a quarter of the moon's mass. Okay, so that's pretty cool, isn't it? I don't know. That's neat to me. So, okay, I just want to do a quick check here. Can you let me know how my sound is, how I'm coming across? I'm hoping that I'm coming across okay, and hoping that the music wasn't too loud. If you could let me know, that'd be wonderful. I realize I've got to wait a bit. Maybe about 10 seconds or so. So I'll do that. Thank you, Ronald. How's the music? Can you hear the music in the background, or is it just not quite there? I can't really tell. I can see that I'm louder than the music by quite a bit, and that's good. All right, good. Thank you so much. Okay. A weird guy. Got all these great questions tonight. What if, after the Big Bang, there were chunks of stuff still massive enough and dense enough to create several little bangs? Whew, wow, that's kind of cool. I would have to say that perhaps yes, Charles, I'll talk about that too. I'd have to say that perhaps the question here is, are there other primordial superatoms like we believe occurred with the Big Bang? And the answer is that we don't know if there were any in our universe, but there may have been others in other universes. Maybe we have to talk about universi, you know, that is to say the plural of universes. You know, that's my plural for universes. But it's possible. So I will ask you guys occasionally how my levels are. Thank you. Bingus, you're funny. That's great. I have the music there. I like music in the background. Whenever I do talks around the country, I always try to have music in the background, because music helps people listen better, and they associate things with what you're saying better. They can remember things better. And I just did a talk in Massachusetts at Eric Hartwig's Mutual UFO Network group. And before that, a week earlier, I was in Florida doing a talk. And in both talks, I did this this demonstration of the history of the Earth, and I used a roll of toilet paper. I actually put the entire Earth history on a roll of toilet paper, I basically toilet papered my audience, and they were okay with it. I thought that was great. So that said, I did that because of the fact that we need to be able to show, the relative creation mechanisms and how things occurred and when. And what people find when I do that is that they see that dinosaurs were rendered extinct only about 18 inches from where we are in that room today. But the toilet paper is over 117 feet long from 4.6 billion years ago. And dinosaurs were made extinct 18 inches ago. So you see that it was actually dinosaurs were just recent history and not ancient history, which is something that people don't often think about. So all right, let's see. I want to go to this next asteroid now, and I'm see, there's so many in the sky right now, so many that I don't even have to spend a whole lot of time hunting for these. I can just go looking, and just the telescope doesn't have to move very far to find the next one. These are all very low to the horizon, by the way. So this one, let's see if we can see this. I'm gonna take a 10-second photo of this guy at 12,800 ISO and see what we get. And here we go. It's been going. And the picture's over in there. Let's see what we got. Oh yeah, look at that. Okay, let's bring that up. Okay, now in this field, you say, well, look, I just see all kinds of stars. But here's the thing you have to understand. The brightest objects that you see in here, the brightest ones are stars, like the one in the upper right. But the one on the left is actually this asteroid. And this asteroid that we're looking at is called 373 Melusina, Melusina. And Melusina is an asteroid that is 14.9 magnitude. All right, and its parameters are kind of like the others. It orbits the sun every 5.5 years, and it's 3.1 astronomical units away, and it's only 96 kilometers across. Well, if you're paying attention, you know that the last asteroid we looked at was only 2.7 astronomical units away, and not 3.1. And it was bigger, so why was it dimmer? Well, it has to do with the brightness and the intrinsic characteristics of the asteroid. The asteroid might be made of somewhat brighter material, and all it takes is for an asteroid to be made of gray material versus black material, and it will show up much brighter. And that's what we've got here. So the best thing to do is to take photos of these things like this, and then come back and take another photo, and then another photo, and then you'll see it track right across the screen, right across the sky. And I think this is a very, very neat way for amateurs to go hunting for asteroids. And Ronald, actually, no, there's no way to see asteroids with your eye. Even Ceres, the brightest one, is not something you can readily see without a telescope. And then, okay. How many kinds of classes are there for asteroids and planets? Okay. Well, that's a whole astronomy class in that question you just asked, Tana, but that's okay. Asteroids are characterized by their composition. Planets also by their composition. Galaxies by their shape, generally. It's a large set of classifications for these different things. And that's actually not a bad idea to go through for a SkyTour radio. Thanks, Tana. That's a great idea. I think I'm going to do that. I'm going to go through and talk about the classifications, the generalized classifications for an asteroid versus the planets in the galaxies, because probably I might only have time to do one each show, because it's so vast and so extensive. But that's a great question. Thank you. Yes, Daryl, Vesta has been at its closest, and I'm gonna go looking for Vesta as well. As a matter of fact, and we did look at it the other day, last time, and so I will search for it, because I know that it's in Ophiuchus, and I want to. See, I already have it in the search bar here because I want to find it. So let's go see where it is. Okay, I was waiting for it to get higher in the sky, actually. But I think that we can go check it out here. Yeah, there's a lot of information on Vesta, let me tell you. Alright, so we leave this guy behind, and now we head over to Vesta. And what is Vesta? Well, Vesta is, and you can hear the telescope moving in the background. Vesta is basically one of the brightest asteroids visible in the night sky next to Ceres, and it's actually the third largest, actually, in the main belt. Ceres is the next one, followed by Pallas. All right, and Vesta is next in line. I think I might have said it's the second largest, and that's not correct. I was jumping the gun there. I was excited to talk about it. So now let's just take another 10-second photo at 12,800 and look for Vesta while the Blue Danube plays in the background. I love this song. I'm sorry. It's like every time I hear it, I see. Oh wow, look at that! Every time I hear about it, I hear this song, I just go crazy. It's beautiful. All right, let's see now. Wowee. Okay. Here's Vesta. Alright, and Vesta is magnitude 5.8, and that shows up pretty brightly. Okay, and there it is. It's down there on the lower left. So let's bring that up, shall we? Let's bring this back to here, and now let's go over and grab it. 5.8 is pretty bright. 5.8 magnitude. Considering that Vega is magnitude 0, and Vega is a very bright star. Okay, and let's take another 10-second photo here at 12,800, because the field stars that we see are actually very important. Okay, sorry about the noise of the vehicles. Okay, let's go here. Let's go. Okay, now let's go check this out. Now, Vesta again is a very bright asteroid. So there you see it in the center of the field, just below center, and it's surrounded by field stars. Okay, and some of those stars we can identify, and some of them we cannot. But you can see a little reddish star right to the left of it, and that's actually, that little reddish star is kind of just to the lower left of Vesta, which is right in the center. And that little field star is from the Tycho catalog, and it's Tycho catalog star 6247-0109-1. Yes, I figure all these things out too. Why not, right? So yeah, so there's Vesta. Vesta's a really cool asteroid there in the middle. And to get an idea of more details about Vesta, you gotta consult. You can consult Wikipedia. You can consult other sources. You can look up Vesta from the Dawn mission, because Dawn mission actually visited Vesta, and it was actually, one of these objects that who was Olbers, I think it was. Wilhelm Olbers, I believe, hypothesized that more objects could be located in the region between the orbits of Mars and Jupiter, and so on March 29th of 1807, he actually he discovered Vesta. So Olbers was looking for Vesta as well. And it's named after the Roman goddess of Earth, you know, home and family. And it comprises almost 10% of the mass of the asteroid belt. As I was saying, its most prominent feature is a really big crater. It's about 505 kilometers in diameter. And you can see this crater on the Dawn imagery. Certainly not on our imagery here, but and it's just it's amazing asteroid. And if you think about it, if you think about this, oh, I see Amanda's joining us. Hey, Amanda, how are you? Yeah. 6 alarms. She didn't hear one. Well, let's just go see if she wants to join us here. Hold on, guys. Amanda, if you can, that's great. If not, it's okay. I understand you've been really had a tough week.
Hello.
Hey, Amanda, how are you?
30-second delay, sorry.
Oh, there is? Oh, not between us.
Well, when I was listening, when you said I'm
Sorry.
going to see if she wants to join, apparently you were already calling, so.
Oh, I'm sorry.
Hey, Al. Hope
Yeah.
everyone's, what day is it? Saturday? Hope everyone's Saturday.
Yeah. How was your day?
Sucked. Absolutely sucked.
Oh,
My
I'm sorry.
aunt is dying, and yeah, I was at the hospital all day, and
Well, you have
tried
all
to
our
lie down
prayers.
for an hour, and, 10 hours later.
Yeah. I think I told you this morning, the best thing you can do is sleep. And maybe you had already done so. I maybe you already fell asleep, But well, I'm
Don't
glad.
mean to break the show down. I mentioned to some people that knew what was going on that I was in the hospital this morning, and then people are like, "Uh-oh, are you okay?" I'm like, "No, I'm fine. I'm just
Yeah.
that's what's going on with me." So and it is actually my mom's birthday tomorrow.
Yes, it is.
So between that and the hospital, unfortunately, we didn't have time to get together and do a pre-record. I may not be at SkyTour Radio tomorrow, so I hope you guys understand. For those that join us at kgraradio.com.
And that's partly that's probably mostly my fault, because she's been saying for a long time that she needed to do the pre-record, and I've been just so crazy busy that I've just not been able to make it a priority, to do it. So if she's not available tomorrow, then you can blame me for that, because that's probably my doing, or is my doing. So I do apologize for that. But there's
Thank you, that makes me feel better. I'm just, it's... Okay, well, I don't want to get into it because I'll start crying. What are we looking at?
this is the Asteroid Vesta. We're doing an asteroid night tonight. And this is Vesta. And I was just telling them it covers, it comprises about 10% of the mass of the asteroid belt, which again is only a fraction of the moon's mass overall, if you add it all together. So it's pretty amazing, But I'm really glad you could join us, by the way. I didn't know if you were still sleeping. I was a little worried about you too, actually.
I just woke up, got the notice late. I actually looked for it to see if you were live, and it did say you were live, and then I got a message saying, "Oh, Mark's live, are you joining him?" I'm like, "Oh, okay." and then I was debating. I was just like, you know what? I mean, it seems like frivolous. I can't say that word, but you know the word I mean. Like, it seems silly for me to be here, but there's not much else I can do but think by myself. So maybe the distraction may be good. So
it may very well help you, actually. I found, when I was recovering myself from, the stuff that I had happened, that distractions were actually helpful, because when your mind is thinking about something else, it's never not thinking about the problem at hand. But you get new perspectives on your problem at hand, so that's all. Maybe that's just sort of gibberish and not helpful at all right now, but, I'm terribly sorry you're going through everything you're going through. That's just, it's not fair. Of course, the person who's, least worried about it is your aunt. because in that position, it's like you don't think about it. You know, it's like that's not even on your mind. You know, taking it from someone who was kind of there. You know, this you know, the people they leave behind are more sad than the person going. You know, it's weird.
That's what's making me so sad.
Yeah.
Her youngest daughter and her husband.
Yeah.
They're dealing with it very well.
Yeah.
And apparently neither am I, so...
You know what? It's okay. It's okay. You know what? We all love you, and we want you to know that it's important that you know you have people here that will help you through this. So,
and it means so much.
well,
just you know, just people showing up at KJRA every Sunday night, the few that are coming over to Earth Radio every Friday afternoon. You know, that just means the world that people want to, you know, be around and support me.
Yeah.
Oh, Echo. Can you restart OBS? Not OBS, but Tana just said I had an echo.
Really?
Yeah, I think you have to remove and re-add.
Oh, okay, so...
Oh, no, hold on. That was when people couldn't hear me.
Okay.
I don't know. I'm not sure. I'm sorry, guys. Sorry for the echo.
Is there an echo? I don't hear it. It might hear it for me.
Tana said there was. I'm just waiting 30 seconds for someone else to comment.
Okay.
Yeah, Charles says...
sounds
like
okay
I'm in a
here.
metal barrel.
Well, Toad says you sound fine. Maybe it's an echo for certain people. It depends, you know, how... I don't know. See, it says... she's saying it's
More
better
like
now.
Reverb.
Sounds better now. See, everyone's saying it's sounds better. Okay, I think maybe just
joining.
Just bring your microphone closer, I guess, and see what happens. And maybe a little more solid sound, like a little better sound might be better. You know, I don't know. You tell me. Hey, Rob.
My voice was actually breaking up, but that was my voice, not that had nothing to do with audio. So technical stuff, but.
I think it was Daryl actually that suggested we go to Vesta, wasn't it you, Daryl? And we did, so I just wanted to check out Vesta and show them Vesta. It's very bright there in the center of the screen. And it's an asteroid, and we have so many of them in our sky. I'm literally looking at probably 500 of them on the screen that we can go see. But we would be here for days just going to look at these. And I just think that's crazy. You know, so let's see here. Yeah,
I was wondering, how are we looking at asteroids? Because I don't see any movement on the screen.
You wouldn't. First of all, this is just a photo. But you wouldn't.
That's what I was thinking. I'm like, this looks like a photo.
No, you're right. But you're also you're right to ask the question, because if you look at an asteroid, even in a telescope, like raw, okay, like for instance, let's just do that. Let's do this now. Let's go back and take. There's Vesta. Okay, let's do another photo of Vesta. All right, and now we're taking another photo of Vesta, and we're taking it about 10 minutes after I took that first photo. Okay, and now let's try to look at this image and then look at the previous image and see if we see any movement. What do you say to that? And you know, I don't know what we'll see. It depends on the speed at which they move, but let's go check it out. Alright, do you see any movement of that? There's one, there's the other. There's one, there's the other. I don't know if you see any. See, that's the previous one.
I see. Oh, can you screen share so I can see it live too, please?
Oh, what a good idea. Yes, hold on, let me just
I'm due one every once in a while.
No, it's okay, it's a good idea. Let me see if I can do this.
Okay, so you haven't moved the telescope at all. This is...
Well, the telescope does... The telescope will actually do a little of that. Okay, how do I, this is not...
on the, move your mouse and the plus sign?
Yeah, well, the plus sign just says more options, and when I go there, it says... It only says hold call. It doesn't allow me to do screen share now. What's going on? Oh, wait, share screen. Okay, here we go. Alright, now you got it. See, it's another Skype version. What do you think, huh? So, now you see it live with me. And...
Oh, and your chat's on the other side. Weird.
What? Oh, yeah. I put it up just to try this new thing. Alright, so now...
I don't like change.
Oh. Okay, let's go here. So, here we go. Take a look at that. You guys see how it... Okay, we have a slight movement of Vesta. You see how it moved from one place to another? That dot in the center. Okay, now the stars did move a little bit too. Okay, but notice that Vesta moved more. Do you see that? You can see it right there. Vesta has moved in the time that we took the photo. Isn't that cool? You're seeing it right there. It's like this is how Clyde Tombaugh found Pluto. This is called it's called a blink comparator. It shows two photos rapidly between each other, and that motion, that relative motion, can be seen very quickly because the eye is the best detector. So isn't that cool? Look at that. You can actually see now. Even though, like I said, even though the stars move slightly, Vesta is moving more between the two photos. And here's what we'll do. If you can remind me, I'll go back and take a picture of Vesta near the end of the night. And we'll look at it again, and it'll be even more obvious. What do you say to that?
If I can remember, I think it sounds like a plan.
That is a good plan.
Now, okay. I understand, well, I think I understand, like... Is it transit? When, like, say, a moon is going around a planet?
You know, like if a planet... Okay, go ahead.
If a planet is going around a star.
Yep.
Okay. And you can see the dimming.
Yes.
Right?
Yep.
Okay. How... Okay, so was Tombaugh doing the same thing as Messier then? Just looking for anything that was moving a significant amount?
Well, actually, Tombaugh was going at it from a point of view where he knew that there was something affecting Neptune, and we didn't know exactly what it was. So, but he predicted where it should be, and that's what prompted the search for Pluto in the region that he was searching. And so he took a lot of photos, and he actually ended up, doing this back and forth with the blink comparator to see where it was. I sat with Clyde, and when he was alive, I sat with him on a rolling grassy hill in Vermont, and we were at an astronomy conference, and I asked him about Pluto and everything, and he was a very small man. I've mentioned this before to you guys. He's literally 4'9", very, very thin, and he talked like this, So he said, "Oh yeah, it was a good thing. I found Pluto, and I did the blink comparator, I saw it there. It was moving, and I was like, wow, that's pretty cool." To him, it was just like pretty cool. I mean, it was the find of the century, and for him, it was just sort of pretty cool. I liked that about him, that he was so humble, really, really humble man, and that's just incredible. That makes him a real superstar in my book. So
I think that would have been really cool.
It was
really, really cool to talk to a guy that found Pluto. I mean, that's that's what I'm thinking. Like, I get if you're looking at a star and you notice a transit. Okay, there's something there. Let's investigate. But so he didn't think he was looking for a planet.
Oh no,
he thought maybe it could have been an asteroid or a moon or just something affecting Neptune, right?
Yeah, he knew it was probably another planet. They were thinking it was.
Oh yeah.
Yeah, he was thinking Planet 9. Okay, and the reason was because the mass that was affecting Neptune was big enough to be what he thought was a planet. It turned out he was right, but his definition of planet turned out to be, the thing that people quibbled over.
Which is what got it demoted, I suppose.
Well, yeah, it got it demoted to a dwarf planet, yeah. And by the way, I'm going to go to another asteroid now.
Well, hold on a second. Daryl just said it turned out that Pluto was not the source of the Neptune problem, though. Is that correct?
Yeah, actually, see, they didn't know what was causing it, but and this points out, I wasn't going to get into this, but it's okay since you mentioned it. The main thing that happened when they were looking for Pluto was that they didn't know they were looking for Pluto. Pluto was a serendipitous find when they were looking for something that was causing the effects on Neptune. Now we know that there's other objects out in the Kuiper Belt that are much more massive than Pluto, and in fact, one of them might be as massive as Earth out there. And no, it's not Nibiru and that, because it's in a stable orbit out there. It doesn't come back and whip into our solar system. If you watched our Universe Sandbox stream the other night that I did with Keith, you saw that we created a Nibiru and brought it into our solar system, and it completely wrecks the orbits if it comes from the direction that Nibiru is supposedly coming from. And if it's on this repeating orbit, it would have long ago wrecked our solar system entirely. You know, the planes of the planets all are in the same plane relatively, called the ecliptic. That's all knocked out of shape by this large mass supposedly coming in. So as long as it's stable out in the Kuiper Belt, we have no problem. See what I mean?
Okay, well, yeah. I don't know. See, I know you want to move on, but I have a lot more questions, and I don't want to take up too much time. It just, okay.
I don't mind you asking questions. I'm going to go anyway, see, because we're not talking about Vesta now. So I'm going anyway.
Okay, but, see, now, if he was looking for something that was affecting Neptune, and he predicted where Pluto was, but Pluto wasn't what was affecting Neptune, like, that just makes the discovery more odd, doesn't it? Like,
well, yes.
How could he predict where a planet was, and he assumed it was a... No, he didn't assume... He did assume it was a planet.
Well, the mass that was affecting Neptune, he assumed, had to be at least a planetary-sized mass of some kind. I mean, not an asteroid, because when Clyde found Pluto, we already knew about a number of the asteroids already. See,
I don't know. I'm just
10 seconds to 12,800. Just announcing the exposure. But go ahead.
I don't know. It just seems like there's something else that's missing from that story. And I don't know exactly how to ask it to get the information I want.
Yeah.
Like, I mean, it's just... But why didn't he find what was affecting Neptune then? Or did he? And it was just something else.
I think that... I don't know... I don't know what it was, but I don't think that it was... I don't think that it was big enough, to affect Neptune. But finding it was still a major find.
No, I know. It just seems more miraculous that he found it when it wasn't. It's like he knew where something was supposed to be somehow, because it wasn't what was affecting Neptune, and that's what he was looking for, and that's what he calculated to find Pluto, right?
Yeah.
But Pluto wasn't what was affecting Neptune, so how did he do it? That's what I mean. It just makes it even more remarkable that he found it.
I don't disagree at all. I don't disagree at all. I agree with you.
See, it seems like there's something missing. Like, then, okay, he found Pluto, and then realized, okay, that's not what was affecting Neptune.
Yeah.
Did he keep looking for what was affecting Neptune, or was he just so excited with Pluto he just spent the rest of his life on that? You know what I mean? Or do people say...
Yeah, I do. I know what
okay, I'll pick up where he left off and try to find what's affecting Neptune. Are they still looking? Do they know? Do they care anymore?
Oh, yeah, they've been looking for a long time, actually. That's why they are hypothesizing now a planet 9 out there. And even a planet possibly the size of Earth out in our Kuiper Belt, in a permanent icy world that's moving forever in a long-term orbit around the sun. By the way, I just want to call your attention to this on this field here. You say, well, how do we know where an asteroid is in this? It looks like they're all stars. if you look at the bottom of the screen, you can see there's a bright star right near the bottom, and then just above it to the left, you see that reddish one. Okay, that slightly reddish one is Tycho catalog star 6223-0545-1. Yes, I know. Very impressive, right? Well, it's in the catalog here. The star below it that I've been just referencing is a star called HD 152-931. And that star is actually a magnitude 8.2. The asteroid we're looking at is an asteroid called 113 Amalthea, which is also the name of one of the moons of one of the Jovian planets, and Saturn, Amalthea. Okay, and
That's pretty.
yeah, Amalthea is a really pretty name, and it's just below center, and you can see it there, and it's a magnitude 11.8. So you can compare the brightness right below center. You see it, and there's a little tiny star to its upper right, little tiny one, very close to it. And then down below, straight down is the reddish star, and down and slightly to the right is that HD star I was just telling you about from the Henry Draper catalog. All right, and 113 Amalthea is the asteroid of interest that we're looking at right now. And 113 Amalthea is it's an 11th magnitude asteroid, and it's in the constellation Ophiuchus at the moment, and it orbits the Sun every 3.7 years. Again, remember what I told you, they're all going to be around that range because they're out beyond Mars. So from like 2.2 plus astronomical units to just 3.5 or so astronomical units, maybe a little more. But that's the main asteroid belt. All right. So now it has a slightly elliptical orbit, so it has an average distance from the Sun of 2.4 astronomical units. All right, and it's a main belt asteroid. Now it's that little guy that you're looking at right there, just below center. All right, is literally only 46 kilometers across. All right, and its distance is 201.4 million kilometers from us. That's it would take light 11 minutes to get here from there, by the way. So you're seeing it 11 minutes old. I think that's kind of a cool way to look at it. All right, so that's 113 Amalthea, and it's just an ordinary asteroid. I can go through the different types of asteroids, and then I was just telling them, by the way, Amanda, that for a future one, and this I think we got from Tana. She actually said this. She wants to know how asteroids are classified, and we did talk about it in one show, but I think it would behoove us to actually do it again, and then talk about how galaxies are classified as well, because there's many different types of galaxies, and we can talk about how they're classified. And then she wanted to know about planets and how they're classified as well, and I honestly, I don't think we've talked about all of those in too much depth. I think we did a little bit on the asteroids, a little on galaxies,
asteroids, yeah, but the planets, I don't think. I mean, right now we're kind of midway through a series of talking about specific planets and how they were formed and whatnot, but not really. I mean, I don't know. Other than terrestrial and gas giants, I don't think we've really talked much more than that about classification of planets. That's a good idea.
Yeah, and there are.
If you can find, would you be able to find all like an example of all the different classes of asteroids to do it on a live stream?
Oh,
that would be really cool.
Well, I guess that's possible. We won't see planets on a live stream unless we just look at what's in our solar system, right?
But all the different kinds of asteroids, though.
Yes. Yeah.
I don't know.
Yeah, the different kinds of asteroids. Like, yes, we'd be able to do that.
That would be cool.
Yep. Yep, indeed.
I'm just trying to think. It just seems so. I don't know. It's really cool that you can say, oh, if you point your telescope here, you'll see this asteroid, because in my mind they're just moving so fast, there's no way you would ever catch an asteroid, but we're getting pretty good at knowing where they are, predicting them, and
yeah,
Do you think you could actually say this is this kind of asteroid, this is this kind of asteroid, and show us in real time? That's amazing.
Yeah, I mean, and we can. I mean, if we, if we just dig into the catalog deeper, which I'm not doing now. Okay. So let's see. Okay.
Nancy was asking if we could turn the music down.
Oh.
And he was on my mind lately too, because I needed a doctor. I went down.
Oh, okay.
Right.
Yeah, see, different songs have different volumes. I turned it down a little bit, but that's okay. Fair enough.
And speaking of Tana and all her wonderful ideas, she wanted to know, does Vega have planets around it too?
Actually, there's a dust ring around Vega, so perhaps there is a planetary system that's in the future for that star, and it may have planets around it too, but we may not be able to detect them yet. That's all. You know.
I like Vega.
Yeah, me too. 26 light years away.
John has a really good question. If we were looking at a deep space object and we heard there was a gravity wave detected, could we go back and be able to see the effects of it? Very interesting question.
If we said it again?
Okay, if we were looking at a deep space object,
yeah,
and we heard there was a gravity wave detected, could we go back and be able to see the effects of it?
Go back where? I mean, we can only go back if...
Like, go back in the stream. Like, if we...
Oh, okay. Oh, I see what you're saying.
Yeah.
Only if we could actually have a record of the object during that time. If someone was photographing it, video capturing it, then yeah. We would be able to go back and see if there was any kind of effect. My prediction is there wouldn't be, but it's possible. But we might be able to check it out. That's pretty cool. Not a bad idea. Not a bad idea. Not a bad idea at all.
That was a brilliant idea, yeah. I guess, yeah. And I guess that's how a lot of these discoveries are found, just looking in the right place at the right time.
Absolutely correct. Okay, let's see. Let's try. Now let's go to this other asteroid, see if we can see it. You'll notice the telescope really isn't moving a whole lot, and that's because there are so many asteroids that are all within the same relative location that it's very, very easy to find them and not have to do anything whatsoever with a telescope to just move a slight amount and you're there. I'm just doing a 10-second exposure at 12,800 sensitivity ISO. Okay,
and Charles has a question, and I have no idea what it means, so...
Okay.
Don't we need 2 detections to find a vector?
A vector? A vector for what?
I don't know.
Alright. Well, fair enough. No, fair enough.
Please?
Yeah.
I don't, like I said, I don't know what a vector is, so I don't know what that question means.
Well, a vector is a mathematical description of an object's...
There, you can stop right there, that's why I don't know what a vector is.
Okay, well, it's a description of an object's motion, okay, so speed and direction, basically.
Speed and direction.
Yeah. So that's a vector. Okay, this guy here now, just so you know, right in the center of the screen there, okay, you can see, trying to see where it is here.
Okay, more on the question.
Yes,
to trace a gravity wave to a section of the sky, don't you need 2 detections to find a vector to trace the gravity wave to a section of the sky?
You have to have gravity waves. Are the ones that we've found are coming from such a long distance away, millions of light years, that you need to have more than one detector, but not the reason for that, though, is because the time between the time that they hit the first detector and then the second detector on the planet is what gives you the information you're looking for. So if you look at like the LIGO detector, the Laser Interferometric Gravitational Wave Observatories, we have two, one in Hanford, Washington, one in Louisiana, and then the Virgo detector, which I think is over in Italy. These detectors were used to basically detect these gravity waves, and the gravity waves were seen passing one detector then the other. Okay, so I think that was I think that's the part that's really important here to understand. And sorry, I'm doing two things at once. I apologize for that.
I know. I'm sorry.
No, that's fine.
Zoned out a little myself. I love chat.
Yeah, they're
wonderful.
wonderful.
Always so helpful. As soon because of the 30-second delay. As soon as I said I didn't know what a vector was, all these little things popped up, these little comments. Oh, it's like this. Oh, it's like that. Right. Oh, okay.
Yeah.
This is such a great community. I can't say that often enough. And this right now is a perfect example of what I mean.
Yeah.
You know, no one's like, you don't know what a vector is? What are you doing on the show? You shouldn't be talking to an astronomer. You're an idiot. You know, it's never in my life have I ever seen a negative comment. It's like, oh, well, I understand that. Maybe I can explain it like that. And
you know why, though? You know why? Because people...
Because they're lovely people?
And not only that, people are very, very understanding of the fact that you're being honest about your knowledge base. You know, if you were trying to be a pretender, trying to pretend you knew more than you did and fake it, they'd see right through. These folks here in this chat, they would see right through that.
Yeah.
You know, you can't go up against people like this. You know?
Well, I figure if I don't know what a vector is, I'm sure there's people either maybe they're in chat, maybe they're too shy to join chat because they don't know.
Yeah,
things,
I don't disagree.
Know?
Yeah, I think that's exactly right, and that's why I think that we would actually have a situation like where we would have. I'm trying to locate this. Or we'd have a you know, with SkyTour Radio, it's like we have that situation where you come in, you don't have all the knowledge, and you say so, you know so. I give what I know, and then people don't criticize you. And remember, SkyTour Radio is a worldwide radio broadcast, and we don't get any negative comments, except from, you know, haters that just hate everything, and then, you know, it's like one or two, you know, and that's been one or two since we started. Okay.
I want to hear about these after the show.
No, I don't even remember. I mean, I would tell you. I mean, you look on the SkyTour LiveStream, you can tell when people make comments sometimes in the chats, or not chat, but the SkyTour comments in the chats of in the comments on the video, they'll sometimes say things about SkyTour Radio, and you know, they basically say I'm not like a real astronomer. I don't know anything. I'm like, oh, okay, well, fair enough. Okay, sure. All right, you know, have at it. You know, go right ahead. You can say whatever you want. I don't have any problem like that. You want to make a comment, that's fine. You know, usually they're flat Earth people though, and they're not worth responding to, are they? You know? Yeah, you do. So let's go back here. Let me turn this down a little right there. Okay. So. Okay, back here now on this screen, I want to show you what we're looking at. We are, and this is where the value of having a time exposure comes from. If we could take a long enough exposure, we would actually see that one of these dots right about here will be leaving a dashed line, whereas the rest would be stars. Okay, this star here is V Serpentis. It's actually in the constellation of serpents, I believe, and it's actually Nu. You know, so it's actually a Greek letter Nu, Serpentis, and so that star is sort of a marker to this asteroid, which is up here. It's it's one of these asteroids. The asteroid we're looking for is right one of these guys in here. And I'm trying to... I can't really tell which one is the asteroid here. I think it's probably going to be either this one or, this one. If you look just in the center, you see sort of an orangey star kind of near the middle, just above center, and to its right, I think that's what we're talking about right there. And that's actually the asteroid 429 Lotis, L-O-T-I-S. And that's pretty cool to try and locate. And I'm not certain, so it's going to be somewhere in the center of that little group of stars, this group of 4 stars in the center. One of those is not a star. One of those is an asteroid. And so I think that's important to note that I don't know where everything is all the time. Now, as I said, we will go back to Vesta and take another photo so that we can see that it moved, because it did move. You saw it moving, but it wasn't quite that obvious. But I'm sure we can make it pretty obvious. All right, let's see here. I'm just having a good time. We're actually, and asteroids, by the way, can be superimposed over anything, including the Milky Way. So let's take a look at some that are superimposed over the Milky Way if we want. But the trouble with that is it'll be very, very hard to identify which ones are the asteroid and which is actually a star. Would have to go back and take long exposures. I'll give you an idea about that in a minute. Okay, let's see. Alright, let's go to this one. Here we go. We're going to move this now to another one. And it's going to be a little low in the sky. Some of these are low in the sky right now, but not a worry. We shall find them.
I may mispronounce this. Alcyone?
That was absolutely not mispronounced. That was well done.
Can we see that star system?
Alcyone is a star that is in the Pleiades, which is a winter constellation. That's Taurus. Yeah.
Give us a month's, Tana. We'll get back to it. hold that.
Just a few months. We'll be back to that. Yeah.
I feel like we haven't even started summer here yet. Up in Canada, surprise, surprise.
Yeah. Well. Well, tonight is actually a gorgeous night. It's a beautiful night, and we're gonna also check out some galaxies while we can. Now, one of the things that I'm trying to find here. Sorry, I'm gonna zoom in here because I want to. Aha. Okay. Oh boy, this is not. See, this is where it becomes tricky because now I'm looking at fainter asteroids, and it's really kind of hard to see where these are and to know where they are.
Well, looks like there's a red one just a little bit diagonal from your mouse.
You're talking, yeah. Well, no one else sees the mouse, but just to the right.
No, I was gonna say, thank God you got a mouse now. They can't see that?
No, they can't see the mouse. I'm actually working on it. I took the entire computer system out of here the other day. I'm working on getting what's called a telestrator for the system, so I can actually draw on the screen and show you things directly. And we are going to do that, but I can't do it yet. I tried the other day, and I had to go back to it because it wasn't really working out. It didn't function at all. As a matter of fact, I was trying to get it to work, but don't worry, I will get to it. I will get it. It's not left my mind. It's the most important thing I want to do, and I will do it now. To the right of center, you see a little red star. Okay, and that is a little red star. That's part of what we're looking at here. I'm trying to. It's not the asteroid, no, but that might be. It might be. I'm trying to figure out what star that is. Yeah, I
wish. We should get Team Viewer.
Huh?
We should get Team Viewer. Is that what it's called?
I don't know. What is Team Viewer?
I don't know. Something like that where I can take control of your computer.
Oh.
I would draw on the screen and point things out and...
Yeah, but it would have to be captured by my black magic card, which is my capture card, to then go out on the stream, because that's all that's going out on the stream is the contents of my card. So you could draw all you want on your screen, but unless it's captured on a second display, which is what I'm going for, incidentally.
No, TeamViewer, I would be in your computer. I would be moving your mouse on your screen.
Oh, I understand. Yeah, that's true. Okay. But even if you did...
It was a joke. Don't worry, I wouldn't. Oh my god, no. Don't ever give me access to your computer.
No, you wouldn't destroy anything. You wouldn't have access to it. Nonsense. Nonsense. You would not destroy a thing. Let's see now.
Not intentionally.
No. Never. Okay, I'm trying to find, Actually, you know what we're gonna do?
What?
It's been about, what, 15 minutes? Since we've gone to Vesta? Let's go back to Vesta. And let's look at it again, take a picture, and see how much it's moved. I bet you it's moved even more. Here we go. And Vesta is actually not too far from where we are, so it makes sense to try it.
See, I don't know any asteroids.
Here it is.
I can't even say, can we look at this one or that one?
Okay.
Although, have never be able to find it again. Hold on.
I think this is it. Well, we're going to do a 10-second shot again, using all the same exposure settings and f-stop settings to try and make this visible and see if we've got it again. Okay, that looks like it, doesn't it? So let's go see now. And we may have to just zip along a little bit here. Okay, good. It's not that way, so I may have to... Okay, that's it. Oh, we're not going to be able to... Let me see, hold on.
See, this is the most frustrating part of trying to do the videos for SkyTour Radio. Is looking for the pictures to match what you're saying, because I know what I'm looking for.
Yeah.
It's just someone has to have thought to put a picture.
Mm-hmm. There it is.
Because I don't know where it is though. I found a list and pictures of all the different asteroid types.
Yeah, we had
that. And now it's just giving me like Ceres, Pluto, blah blah blah.
Yeah.
No, not Ceres and Pluto, sorry.
I know what you mean, no. Ceres is an asteroid, a dwarf planet, but...
Yeah.
Okay, now, I know that it's hard to see here, but you can see... Oh, okay, it's really not that obvious, is it? Okay, you can see it. You can see that it's moved a little from this one to this one, but then I would have had to have just stayed here in this field to take this next picture here. But you can see that it's actually moved a little bit. If you look at the red star to the lower left of Vesta, which is right there in the center, look at that little red star and compare it to this position here. You see that even though the star shifted a little, you see that Vesta has shifted more. But then unfortunately we come down here and you really can't tell, but the distance between that red star and Vesta has actually increased a little bit. Okay, you see how, look at the distance between Vesta and that little red star to the left. And now look at it here. You notice it's more. It's a greater distance. We're actually seeing how early astronomers discovered the asteroids by looking at photographic plates and seeing what moved in the interim. And that's what we're seeing here. Same kind of thing. So once again, okay, if we go back, all right, between this photo and this photo, there's a slight change. Again, just look at Vesta in the center and look at that little red star to its left and a little bit lower. And you can see that Vesta moves against that red star, relative to that red star. And then if you can take the jump, you can see that Vesta's moved a little farther from that red star here. If you were to measure the distance from Vesta to that lower left, slightly lower and to the left star, that's about 6 or 7 Vesta widths away, just to its lower left. you'll notice that it's a little far. It's closer here, a little farther there. So that's a live view of yeah. It's right, Daryl. It's like doing a blink comparator, but live. It's a live dynamic.
Is it kind of like parallax?
No, it's a little different because, well, it's very different because
Just that it's not as long of a period. That's usually 6 months.
No, we're actually watching move. In a sense, okay, you could use parallax to determine the distance directly of the asteroid. In fact, between those two photos I showed you, we can actually get a parallax value. But the trouble is that Vesta.
We're just one location.
Well, the trouble is Vesta is moving, and so that messes with the parallax value as well. Okay, so you would have to use a short amount of time and get an accurate measurement of the very, very small, minute change of Vesta to get a proper or a more usable parallax. Because if it's moving quickly, then the parallax angle is skewed. All right, and you might get a distance that's a lot closer than it should be.
Yeah, I thought that's what parallax was, like watching how far something has moved from, say, January to July.
No, it's parallax is a little different because the way it works is usually with stars, and I worked in the parallax program measuring distances of stars, and the way we worked it was this: if you were on one side of the Earth's orbit, okay, let's say you're it's in the winter time, okay, and you look at this particular star, and then you wait 6 months, all right, and now you're off in the summertime, and you're looking at the same star. You may notice that that star's relative position, compared to the stars that it's in front of, okay, is now different. Well, because stars move through space, as long as they don't have this massive motion through space, like some stars we know have, like Barnard's star, it moves this massive amount of arc seconds per year in the sky. Because if it doesn't move that much, then you can actually get the distance to the star with relative accuracy. So that means that it's like, you're blinking your left and right eye with your hand extended and your finger up, okay, and you're seeing your finger change against the background of the wall. You're seeing how it seems to be to the left of the spot in the back wall and then to the right of the spot in the back wall when you blink your left and right eye. Well, your left and right eye corresponds to the left side of Earth's orbit and the right side of Earth's orbit. And your finger is the closer star and the wall are the farther stars. So that process gives you an angle called a parallax angle to that star. And that's a very useful item. We can classify objects out to 300 light years using parallax and figure out how far they are with parallax. That's really good. So we had some fun looking at these asteroids tonight, but I want to take a look at some of the up and coming objects and some of the objects that will be leaving us behind here soon. I mean, because it's already 11:20 and we started at 9:30 or so. So we're actually doing pretty good, and I want to try and keep it 2-hour streams, but I won't stick to that if we have some really cool things to look at. Yeah, and let's see what we got there. Yeah, I think that's... Just hang on, I'm trying to see. Okay.
Our next destination?
Yeah, I got it now, and I'm going to go there now. Our next destination is not going to be an asteroid, but an object, and a kind of a cool object at that, if we can actually see it. I've never viewed it before, so we'll see. We shall see.
And you say it's a deep space object. That could be anything.
That is correct.
Quite the hike. Jenny, are you hearing this?
What's
that? I hear that, like the grind of the telescope.
Oh, yes. I'm glad that Jenny's here listening to us. Let's see here. Oh yeah, there it is. Wow. Okay. So sometimes some objects are just really neat. Okay, to the left of center, you see that red object. Let's just take a photo of it. 10 seconds again at 12,800 ISO. So it'll be here and gone in no time. And it'll be back here in a second. Yeah.
Ooh.
Yeah, well, there's also that star. Okay. Okay, so now, that star to the left there.
The red one?
Yes, the red one to the left. Let me just do this. I think I gotta make sure that we're focused here. I might want to alter focus a bit. Not sure.
Is this a binary star?
No, actually that star you're looking at right there in the center, just about. I'm trying to move it there now. Okay. Alright, there you go. Just below center. Okay, that star is actually called V419 Cepheid. It's in, Cephus, so Cepheid, I guess. And it's a 6th magnitude variable star. So it's a variable star, meaning it changes its brightness. And it's 2,817 light years from us. Alright? So you're seeing it 2,817 years ago. Alright?
Wow.
And yeah. And it's a red supergiant. Okay, and it's spectral type M2. And Amanda, you know the spectral types, spectral classes rather, and they are
OBAFGKM.
She's gonna have that in her sleep, folks. She's gonna be dreaming OBAFG.
It's getting faster.
It is.
It's
that was really
faster.
well done.
Well, the first one's like OH is still O, BE is still B, A is still A. So the first few I can do no problem.
Yep.
It's when I'm substituting words and just dropping it to the letter.
All right.
But it's getting faster.
It is. You're doing well, very well. Yeah, this is an M2. This is an M2 1B, which is basically it's a red supergiant. Surface temperature is 3,000 degrees. Well, 3,000 Kelvin. There's degrees and Kelvin don't go together.
And this is the coolest on the scale.
It's right. It's very cool on the scale. It's an M-type star, but
and it's still that hot.
Well, it's actually it's 3,000 Kelvin, and it's about, just so you get an idea why it's so visible to us when it's so far away, is because this star is actually over 226 times the size of our sun. 226 times the size. Can you believe that? And it's 19 times the mass of our sun, which means less to you, I'm sure. But when you calculate its luminosity, because luminosity depends on radius, that luminosity is basically the overall brightness, the intrinsic brightness of a star, okay, or an object out there. This thing here is 5,900, almost 6,000 times the sun's luminosity, and that is very, very bright. And it's what's called a long period variable. So its magnitude varies between 6.3 and 6.6. So it's not that much of a difference, but it has an irregular period. So it's an unknown, period to it. But it's literally 2,800 light years away. That's incredible. And I'm just a big fan of stars that are far away, that shine so brightly. What can I say? Now, if there were planets around that star, they would probably have long been, burned to cinders, as the star had changed to a red supergiant. Because it was a normal, what we call a dwarf, or it's, fusing hydrogen to helium. It was doing that normally for some period of time, But this is just one of those stars that is just kind of cool, Again, 226 times the size of our sun. And it's there.
Tell us about the blue one.
The blue one?
Yeah.
Oh,
Nothing.
no, I can't. I started moving away from it. Let me just see if I still have it set here. Okay, that blue one you were talking about. Yeah, that's a good point. I gotta find that. Find the blue one. Yeah, I don't...
Well, you knew I was gonna throw it out there. I probably shouldn't have.
No, it's okay. I don't mind.
Wasn't really the purpose of coming here, but
That's alright. I don't have all the answers, but that's okay. I'm looking to see if what that star might be, and it actually is a good star to use as a indicator for me here, because I might actually let me do this first. Ah, see, going up. Oh, there goes that way, huh? Oh, I see what's happening here.
Mark is calculating.
I am. I'm actually seeing that I got something wacky going on here. That isn't right, is it? Wow. Okay. A little bit of a issue here with my system. I'm trying to figure it out. That's crazy. Yeah, no, don't worry about me. Nothing to see here, folks.
Well, we do have a question. I just don't want to distract you, so.
No, it's okay. Quiet. I mean, you can go ahead, because I'm the star that is supposed to be there isn't there.
Oh my goodness, you lost the star.
No, actually, I didn't. Maybe I found something new, which is kind of weird.
Have you ever heard of Alcyone being called our central sun?
No, I don't know what Tana's talking about with that.
She said she saw a documentary, and for some reason, I don't know which documentary it is. Tana, if you know the name of it, you can drop it in here. Yeah, in a documentary she saw it was called the Central Sun, and she was just wondering why it was called that, but you've never heard it.
No, it's probably some kind of pseudoscience, and the thing is, it's not Tana's fault that she saw it and thought it was interesting, because most people seeing these documentaries, they're presented in such a way to look so authoritative, but in fact they may not be authoritative. They just might be a bunch of hoodwinking, going on for all we know. I don't want to say that's what it was. That's kind of sad to think that it might have been. Okay, but it's really could be.
Well, I noticed Tana's really been doing her research.
I know.
Comes up with amazing questions, and they're always so detailed about specific things.
Yeah.
That you can tell she's been researching on her own, and I don't know if she writes them down or what, but just remembers. But no, every time she drops by, she's asking really, really detailed questions, and it shows. Good job, Tana. I wish I was that dedicated to be doing more research on my own, but sometimes my brain needs a break after. I don't want to say dealing with Mark, but. See, this is all basically
that's
new
fair.
Information to me
that's
from
enough.
High school science to professor level astronomy. So.
Well, see, astronomy is something where you never stop learning. I just moved to another object, by the way. It just happens to be in the same spot, apparently. But this is another star that's about 2,400 light years away, and it's a very, very famous star. Actually, it's a variable double star in Cephus, which is about what did I say here? It's 2,400 light years away, and the stars are separated by 19.4 arc seconds, and I'll take a picture to show you. And that's about 14,500 astronomical units. But at 2,400 light years away, that they still, they don't have that vast amount of distance. They seem to be apart from each other. But I'm taking the photo now. What's a Cephid? A Cephid is actually a type of variable star. Cepheid, we call them Cepheid variables, actually. And some people call them Cephids. All right. Now. Okay.
So it's not like part of constellation then?
Oh, it is. It's based a Cepheid variable. Cepheid or Cepheid variable is one that was seen in the constellation of Cephus. Okay.
So that's what I'm saying. What's the Cephus?
It's a constellation, a northern
Oh my
constellation.
god! No, but I mean, what is this supposed to look like?
Oh, it actually kind
Like
of
Gemini is supposed to be twins.
Yeah, you know what?
Yeah. What's the Cephus? For some reason, I'm thinking like a beetle, but I don't think it is. Like
No.
it seems like an insect or something.
I know, right? No, I don't. I actually.
Cepheus, I don't know.
Well, I'm having a
the
brain.
king. Cepheus, the king.
King Cephus,
okay.
right?
Thank you, Daryl.
Yeah, but this is actually what you're looking at here on the screen. This is called the Garnet Star, and it's Mu. Okay, the Greek letter Mu. Mu Cephei, which is Herschel's, famous Garnet Star. It's one of the most deeply colored stars in the night sky. It's really, really crazy, and it's also a red supergiant star. All right, like the other one we just saw.
There's a Pokemon called Mew.
Huh?
There's a Pokemon called Mew.
Well, yeah. I mean, I'm sure they borrow. It's a loan word.
It's a cute word.
Yeah, it's a Greek alphabet. Alpha, beta, gamma, delta, upsilon, zeta, theta, iota, kappa, lambda, mu. Okay.
Mew?
Yeah, nu, xi, omicron, pi, rho, sigma, chi, epsilon, phi, keep, psi, omega. I mean, that's the whole Greek alphabet. But I mean, mu here is just that star that is that relative brightness from Alpha, which is the brightest in the constellation. And this is literally, this star you're looking at is one of the largest and most luminous stars in the Milky Way. Now, it's also, for those of you that know the story Dune, okay, Frank Herbert's Dune, this star is also called Arrakis. But Arrakis is spelled E-R-A-K-I-S here and not A-R-R-A-K-I-S like in Dune. But that's it's in this particular Mu Cephei was first named the Garnet Star by Giuseppe Piazzi in his Palermo catalog of stars, and that was in 1783. Now Herschel noted this star that had this very deep garnet color, and it had this periodical variability to it, and thus this garnet star became Herschel's garnet star. And it's also associated with a very large region of nebulous cloud in the constellation of Cepheus, and that's right surrounding it, and it's part of it. But this is a very luminous M2 supergiant, right? M21A, as a matter of fact. So Mu Cephei is one of the largest and brightest stars visible, and it's visible to the naked eye, but it's also the brightest, literally one of the brightest stars in our galaxy. The distance isn't really well known, so the distance of 2,400 light years is kind of a estimate. And parallax measurements and distance estimates, give values between 390 and 1,600 parsecs, which is, a parsec is 3.26 light years. So you can multiply 390 times 3.26 to figure out the lower bound, and the 1,600 times 3.26 to get the upper bound. So, even at this kind of this uncertain distance that we see here, it's really big enough to show a measurable angular diameter, which we know that only the biggest stars, we can actually see their disks in the night sky. And that's basically the size of this in the sky. If you could see the disk of the star itself, it's 0.02 arc seconds. Now, that's a tiny amount. And the glare we're seeing on the screen corresponds to like 50 to 60 times that. So, yeah, we're looking at a much, much bigger area here. But that's about 1,420 times the size of our sun. So 1,420 times the diameter of our sun is the size of this. Now, if you want to know how that is in astronomical units, if you put this where the sun is, this star would extend out to 15 astronomical units. Okay? 15 AU. That's incredible. Okay? So, that'd probably be like about midway between Jupiter and Saturn, okay? And you could put 1 billion with a B suns inside of it, right? And
between the halfway point?
What do you mean?
Between Jupiter and Saturn?
Yeah, but
you said it would be like halfway between Jupiter and Saturn.
Oh, if you put it...
the halfway point could fill a billion suns?
No.
Or... No.
If you put it where the sun is, then it would extend out to partway between Jupiter and Saturn.
Oh, okay.
And you could put over 1 billion suns inside of the sphere of that star.
Okay, sorry, I got you.
It's amazing, okay?
That's crazy.
Yeah. And of course, it's a variable. Most of the supergiants are. So we're looking at some really cool... Hey, Dee, how are you? We're looking at some really cool stuff there, you know. And so I like... Objects like this are just really, really exciting to look at because of the fact that, you know, most folks, most of you guys haven't really ever seen these, or if you have, you didn't know the history, you didn't know the backstory, and I just think it's pretty cool, don't you? You know, I think it's really cool, but that's just me. What do I know?
I think it's very cool.
Yeah.
I was taking a sip of pop on you, though.
Oh, that's fine. That's fine. You deserve a sip of pop.
Soda.
Okay.
Soda pop?
Yeah, I know. I like that pop, you know. So because it's such a nice clear night, I want to try and look up some of our favorites here. Yeah. And I'm just going to look out the dome and make sure that it still looks as good as I think it still looks.
What do you know about Alcyone?
Well, Alcyone is a bright B-type star. I can see the Milky Way through the light in my dome here. That's incredible. Alcyone is a B-type star, and it may be I know it's a double star. It might be a trinary and possibly a quaternary star with 4 components that are gravitationally bound to it in the center of the Pleiades.
So what is Alcyone? It's a star, so it might have like B, C, and possibly D and E. Is that what you're saying? No. No, that's planetary. We're talking about Alcyone having basically just 3 other stars that it's. Oh, okay. So all stars.
Yes,
no
3 other
planets.
stars that are part of its system. I mean, and no planets. The B stars typically, as far as we know, actually, B stars do not have any viable planets. Because of that. I'm just putting up my hood because it's actually chilly in the dome already. You guys, you can't understand, I don't think, that it's really hard for those of us who hate winter to have a chill going on like this. But the sky is beautiful, and I'm not gonna. I just can't stop. I'm crazy. Okay, let's go take a look at a couple other things here. If you have any questions, now's the time to ask, because I'm
yeah,
trying.
More on Alcyone, please. It's a B. Okay, so now let's say hypothetically, it has 3 other stars, so it's a quaternary star system or whatever.
Possibly.
Okay, well, let's just say, so what are these stars doing? Are they orbiting each other? Are they just traveling through the sky together? What are they?
Well, they were all born in the same location. And that's the thing about with Alcyone. I'm moving to another object, by the way, in case you're wondering what that noise is. Yeah, they were born in the same location in the sky. Yeah, here we go. This is gonna be pretty. If this works. Wow. And so they'll end up. Oh, this is one of your favorites, I think.
Is it the Midnight?
Well done. Yes. Okay. This is gonna be 10 seconds at 12,800. Alcyone is a bright blue star, and speaking of bright blue objects, let's take a look at this guy here, which is a nebula, of course, that we've talked about before, and it's very overexposed here, but let's just zoom in on it anyway, just to see it.
Now, if Duplicate was lurking, this should draw him out.
There it is. Look at that. Yeah, that's actually the cat's
eye.
Yeah, cat's eye. Thank you, cat's eye nebula. Yep.
It is so hypnotizing. Like,
well,
it seems like the brightest thing we ever see in the sky.
Well, let's do this. Let's move it to the center.
And it can't be biased because it always does it. Once you zoom in on it, it's like that's the only thing on the entire screen I can see.
Yeah. Well, here's what we're going to do.
Although I did see a little lighter blue one, kind of to the upper right of it.
Well, you know what we're going to do?
What is that?
I'm going to cut this down to like a 2.5 second exposure at 12,800. And then let's take a look at what that does. I want to see if what it takes to get some detail in the middle of it. Well, you see the other stars, right?
I do.
Yeah.
When I try to physically take my eyes off Cat's Eye Nebula.
I know. I mean, this thing sometimes it's kind of weird, you know. Now let's go to literally 0.6 seconds, and let's try this. All right, and let me see what we can do here. That's interesting. It has a kind of an interesting shape. You can see that it's not quite round for sure. And I mean, I could spend a long time trying to, fiddle with this. But I just wanted to bring us there for a minute because you were able to join us tonight. And out of respect for you and everything that you're going through, I thought maybe the Cat's Eye Nebula would perk you up a little bit.
Yeah, it's beautiful. Thank you.
Of course. And then let's see.
I'm just gonna pretend like every time you ever come here, it's for me.
Well, you can do that too. You can do that too.
In my own little world sometime.
That's right. We're all allowed to live in our own little world sometime. Okay, let's try this. Let me see what we have. Okay.
What are the chances of seeing any planets?
Oh, we got plenty of planets out.
What about,
We have Saturn, we have Mars, we have Jupiter. Mars is in the middle of a dust storm.
Yes, I know.
Yeah, I know.
Stay tuned to SkyTour News if I ever get it done.
You will.
I just have to get pictures and put the video together. The recording's done and the editing.
Nice. Okay,
and
so
technically it's already Sunday, so
yeah. Okay, let's do this and this. Sorry, I'm just gonna get this over here.
Because we had a discussion about Neptune and Uranus, about the blues.
Oh yeah, that's correct. We did.
Because I thought Neptune was more like an aquamarine, and that Uranus was more like a darker blue. And
we had that discussion because you thought Sailor Moon, that Japanese anime, had Neptune as a darker blue or as a lighter blue, and Uranus as a darker blue. And it's the opposite.
Because I was sure when we looked at Neptune live in your telescope, I remember saying, "Oh my God, that's the exact color of Neptune's hair. Maybe not her skirt, but her hair."
Yeah.
But then Uranus's skirt was like almost like a dark, I don't want to say navy blue, but like a dark blue. And it's actually lighter than Neptune in real life in like a telescope.
That's right. See, that's...
They're saying my audio's still rubbish, by the way.
They are?
Yeah. Rockstar said that.
Oh. Well, I'm sorry that that's the case.
Sorry, guys.
I don't know why.
I feel like I'm on a spaceship.
Why?
Oh, no, he said it sounds like I'm on a spaceship. I don't know, mixing up days and times and...
Yeah, you're on Spaceship Earth, man.
Yeah. Again, off in my own little world, and I took the spaceship to get there.
Yeah. Okay, let's see this now. Let me try something here. Alright, there we go. I'm fine. Okay. Okay, well. Okay, these two stars are just... They're two stars in the constellation Draco that I'm looking at right here. And they're very interesting because they are double star. And it's called... let me find it here. It's actually... it's Eta Draconis. It's a second magnitude double star in the constellation Draco. I figure we're on our way to see some cool things, so why not go check it out, you know? And
makes sense.
Yeah, and the thing is, the thing that's just above center is not the double. Okay, the star that's got a double is this one down here, and I was actually trying to the one at the bottom, and I was trying to actually find a way to see if we could see the double. It's not that one to the right either. It's actually it's that star, which is the double right there, and I can't see it. It's the separation is just a little, just out of my reach. But I could also be a little out of focus too. So I'm gonna check the focus here in a minute. Let's do that by going to another location. I want to take us to. Let me look out the dome here. God, it's beautiful out here. Oh, I'm not gonna want to leave. I'm not gonna want to close up tonight. I know it. Oh, Cygnus is high in the sky. The Milky Way is the most beautiful I've seen in a long time. Hey, I know what that means. Oh, jeez, why didn't I think of this before? Wow, Cygnus is perfect for this right now. We're gonna go try and take a look at something else. And that something else is going to be...
Cygnus?
Part of Cygnus, yeah. We're gonna look at this object here, hopefully. Yes, we are. Find it. Just a moment, I'm getting there. Okay. Okay, and where'd you go? There we go. This is one we've seen before, guys, and I think that it's going to be pleasant to look at it. So here we go. Alright. I'm ready. Let's see now. Okay, that star is very important to us.
Why?
I will show you. Because now we're going to go here. And then go here. Okay.
Oh, I have a request after this.
Okay.
If we can see it.
Alright, hold on. I'm glad. We'll check it out. Alright, this is going to be a 25-second exposure. And I'm going to drop it. I'm going to bring us up to 20,000 ISO sensitivity. So 25 seconds at 20,000. Let's check it out. And then we'll see who recognizes it.
For the smart people out there, it sounds like we went like a whole 180 degrees, so...
What's that mean?
Whatever we were just
distance?
looking at. Yeah, whatever we were just looking at. Think what would be... complete, like if you actually turned around, what would you be looking at? Ooh, I think I have a guess.
Look at that. Isn't that beautiful? Look at how beautiful that is. That's nice. Oh, that's gorgeous.
I'm putting my guess in Skype because before it comes up anywhere else. I think I misspelled it, but oh well.
Okay.
Typed too fast. Okay.
It actually looks pretty. Let me see what you said.
Don't show them though.
They can't see what's in Skype.
No, Daryl, go ahead. Everyone take your guesses. What do you think we're looking at? I'm probably wrong.
I can't tell how to get to the chat from this. It's down here?
I don't know.
Maybe it's this.
That's a weird looking Skype.
It is.
Everything's backwards. Is that what we're looking at?
Yes.
Yes?
Yeah.
Okay.
Daryl. It was a long slew in a sense, Daryl, but the problem was that we were looking at... I've actually cut down the speed of the slew. What's a slew? The slew is the motion in which a telescope goes from one place to the next. I cut it down. I made it slower, and the reason I did that was because I wanted to allow the telescope a little bit more accuracy, and that helps me. That helps me with accuracy.
I cannot believe I got so excited and I was so sure I knew what it was, and then the doubt came pouring in. I'm like, no, there's no way I would know something like that fast.
Yeah.
But apparently, it's just a matter of which side, really.
Yeah.
And I saw one right answer so far, and Daryl gave a really cute hint. Well, it's cute if you know what it's called, I guess. It's not much. It's not a train.
Where's this hint? I didn't see it.
Oh, it's worn by the bride.
Oh.
So I'm saying it's not a train.
Daryl, that's a good one.
That is a really good one. It's really cute.
All right, we're gonna now take us to another spot, which is right
Wait
here.
a second. Hold on a second.
Oh, no. Don't worry. It's the same thing. It's an extensive object. We're gonna look at another part of it.
Okay. Yeah, Tana guessed that maybe it was Orion. It is not Orion.
No. And now we're gonna
There is one correct guess though.
We're gonna do another 25 seconds now. Is that correct? I can't tell if it's going. Shoot. I may blow this exposure. Yeah, I'm gonna. Okay. Oh, no, I didn't. Okay, good. Okay, 25 seconds at 20,000 ISO sensitivity. On our summer preview special here on SkyTour LiveStream. This will be the other half of the object. And we're waiting for it to come in. Oh, it's pretty. Okay, and let's go look at it. And the things to pay attention to are what you see just to the left on the screen there. Okay, on the left, that's something that's actually pretty interesting. That shows you can see all the complexities in there. No, Tana, not the Seven Sisters.
No,
Nice try.
She got it. She got it.
She did?
Yeah. John was the first one to get it.
Oh, yeah, the Veil. Good, yeah. Good for you. Yes, this is the Veil Nebula. That's a supernova remnant in Cygnus. And it's so extensive we can't photograph all of it in one shot. And that's because when the supernova, which was formerly a star, exploded, okay, this object, which is 2,600 light years away, started to expand outward with the debris that it released in this explosion. And discovered in 1784 by William Herschel, it's literally 6 times the diameter of the full moon. Okay, it's a round, expanding nebula, 6 times the size of the full moon. That is huge. And everybody that's looked at it has classified it into separate objects because of the fact that it's got such a varied look to it. Whenever you look at it, it's like there's literally 1, 2, 3, 4, 5, 6, 7, 8 different elements to the veil, and this one here is what we call the this is the eastern veil, and the spindly one was the western veil, the one closer to where the sun sets, that in that direction toward where the sun sets. And it's basically a spherical shell that's expanding from the location where this occurred. So it's really amazing. I'm sorry, I was looking at something again. But if you look, you can actually see the colors so well. I can't get over it. How when I look at this, I just lose myself in it. It's just so incredible to see this thing.
See, and I wasn't even thinking the veil was in Cygnus. That would have been a good clue too.
Oh no!
I actually just recognized it by looking, which is why I doubted it. I'm like, no.
No, that's good though. You got it. Yeah, but you see here, here's what's important. Check this out. You can see areas that are reddish and areas that are kind of blue. And just so you know, you can't see that with your eye when you look at it. You basically see a little hazy look to it, and that's all you get to see when you look at the veil with a telescope directly. But when you use a camera like this one, you actually bring it out in just exceptional detail. And that's what we're seeing here.
Now, what if you used, I forget what it was called, the lens where you can see the spectrum of things? What would that look like? Would it just be like big dark gaps all over the place?
No, those are actually emission nebulae. Those are giving off light, and so you would see a line, these lines of emission, as opposed to lines of absorption that we see in spectra.
What are the Balmer lines?
Well, the Balmer lines are for hydrogen, and those are actually...
Okay.
See, the way that works is there's emission nebula, and there are emission spectra and absorption spectra. What's the difference? Well, the difference is, and I'm doing another 25 seconds at 20,000 ASA here. The difference is that when you look at a emission nebula, you're looking at what happens when gas is heated and excited by high frequency light, like blue light, and the electrons get so excited that they actually bounce right out of the atom. But when they come back into the atom, they come in a characteristic manner depending on what they are, and they emit a certain characteristic light, again, depending on what they are. Alright, so when you look at, for instance, this nebula here, alright, on the left side you see kind of a bluish haze there, which is gorgeous. That bluish haze is oxygen, but doubly ionized oxygen. We call it O3, Roman numeral 3. Alright, and you'll say, but wait, doubly ionized is only 2. Maybe isn't it? Why shouldn't it be O Roman numeral 2? O2. Well, because the O1 state, where the Roman numeral 1, or anyway, the Roman numeral 1 with any element, is what's called the ground state. Okay, where it has all its electrons. But when it's singly ionized, right, and it loses an electron, then it becomes the O2, the O Roman numeral 2. Same thing with hydrogen. H1 is just regular hydrogen, and H2 is singly ionized hydrogen. You can't have H3. that would be doubly ionized hydrogen. You can't have that because there's only one electron, and an electron is only ionized. You can only ionize one electron, so you can't ionize that same electron twice. Okay, at the same time. So you only have it. You only have H2, which is the Roman numeral 2. So that's what we mean by H2 regions. That's what we mean by hydrogen alpha, because when the electron jumps off the atom and leaves only the proton behind and say hydrogen, that electron will then recombine with the atom spontaneously over some period of time, and it may not even be the same atom. It might recombine with another atom that's lost its electron. But the point is, it's actually a process called recombination, and during that time, the atom jumps or the electron jumps to a very specific spot and loses a very specific amount of energy when it comes back into the atom. And when it does that, it gives off a certain characteristic color light, and that's what we see here. Okay, the reddish is the hydrogen alpha, or the recombination of hydrogen atoms coming back into the hydrogen, or hydrogen electrons coming back into the hydrogen atom, and the blue is from the oxygen, and there's a few other elements in there as well. But that's how that all works, and it's just it's sort of an interesting process to understand. See, I figured I stopped talking to let people absorb, All right. So the veil is just beautiful. I absolutely love the veil. Let's see if I can. Let's go do one other thing. Let's go to 25,600. Let's literally go up by 2 stops in 30 seconds. All right. So now we're gonna capture the veil for 30 seconds. The same picture, 30 seconds, but at another higher sensitivity, so there will be a little more noise in the image, but a little more detail as well. So 30 seconds at 25,600 ISO. Yes, indeed. Man, I cannot wait for summer's arrival, guys. This is gonna be beautiful. Beautiful indeed. Oh yeah, look at that. You can't miss the veil, man. It's just beautiful. Look at that. I think you can actually see now what I'm talking about. You can actually see a lot of these detailed convolutions now. And there, right there on the left side, you can see that blue, and just below you can see the reddish. Okay, that combination is very visible, very obvious. Okay, not bad at all. And I'll just come out for a second, go back in without. It's there. Now you can see the full image. Wow, isn't that pretty? That is just beautiful. Indeed.
It is. It's lovely.
Yeah. Yeah, Daryl's right. In the Dumbbell and the Ring Nebula, you also see that green, that greenish blue. Again, that's what they call a forbidden line of oxygen, O3, O Roman numeral 3, and that O3 is actually. They call it forbidden line because it can't be reproduced on Earth under normal conditions under the atmosphere, because the atmosphere is too dense. You actually need a certain rarefied gas. You need the gas to have fewer atoms in it per square centimeter, and under those conditions you can get the O3 transition to occur properly, like we see here. Same thing with these other nebulae. So I'm thinking it's really it's a very, very good lesson to learn about how this all works. Okay, let me.
Okay, well, speaking of how things work.
Yeah.
Yeah, I'll bite. We want to know where people get helium to sell like balloons. And Daryl's saying Kansas. Charles is saying Texas. And I know they're all being serious, so...
Well, what do you... I mean, helium...
Like, how do you... I guess... I don't know. How do you figure out the processes that stars create these things on Earth? Maybe that's what he's asking.
I'm not sure actually. Or while I'm working on the next object to go to.
Like, I can't remember the name of it. Aren't they trying to do something and smash something together to create another Big Bang? Like, how do they... I don't know, how do they pressurize hydrogen to make helium to actually contain and then sell in tanks to inflate balloons to sell?
Oh, they don't do it with fusion. No, that's not how that's made. Helium occurs naturally in relatively few areas, and so they can extract the helium and tank it that way. Frankly, and that's what they do.
Oh, cool.
Yeah, but yeah. Besides, if they...
Yeah, John wants to know, what's helium even doing here? So it's under the ground like you would, like, drill for oil?
I'm trying to remember how they extract helium. It's not... helium is very... It's not as light as hydrogen, but don't forget, we also get hydrogen, too. We can get hydrogen gas as well, and that's another one that's done this...
Ground?
Well, it's bound up in a lot of compounds, so it can be extracted like... It's right in water, H2O, So if we
I never really understood that, though. I don't understand, like, how you could separate helium or hydrogen from 2 oxygen to...
Well, 2
no,
hydrogen
hold on,
from
2,
an oxygen.
yes.
Yeah.
I realized I said that
That's
backwards.
That's okay.
But how do you take the oxygen out to change water into... I don't know, nothing, air, I don't know.
No, you break the bond between the diatomic H, the hydrogen, and the one oxygen atom that's attached. Atoms are bonded to each other with different kinds of bonds. You have a covalent bond, you have ionic bonds, and this is the way in which they share electrons, say, between them, and that's a bond between the 2 atoms. Or they can bond in different ways. And when you have 2 hydrogen atoms that are bonded to an oxygen atom, if you apply some energy to that molecule of H2 and an O, okay, you can split the bond between the hydrogens and the oxygen, and further split the bond between the 2 hydrogens. I did that as a kid. I made hydrogen balloons that I used to blow up in the empty field next to my house. And I did it by giving some... I was like probably 12 years old when I discovered how I could generate hydrogen gas from a very hot process using sodium hydroxide as a catalyst and metal shavings as something for the sodium hydroxide to attack, and with water. So the water was mixed into the sodium hydroxide, so H2O plus NaOH, with this metal catalyst would yield hydrogen plus more water, and I didn't know about the chemical reactions then. I didn't know chemistry when I was 12, but I did know that the gas coming off was highly flammable. And so I said, ooh, I'm going to have fun with this. And that's when I chose to start, going down the path of generating these hydrogen balloons, which I would then toss flaming arrows at or whatever. And I ended up, it brought the cops every time, let's be honest. I mean, because I would always just go ahead and, I would make this...
You're a little delinquent.
I was a little bit of a... Yeah, I was curious. That's all.
Mm-hmm.
What's wrong with that?
When fire arrows come into the picture.
Yeah, no. As soon as you start talking about fire arrows, yeah, I get it. You're right. All right,
and exploding chemicals, yeah.
Oh, yeah. Well,
but I mean, see, to me, like... I don't know, that's too crazy to comprehend, and this is probably where I ended my science career in high school, was with bonds and things like that. Like Like, I want to see, like, you know, you take a drop of water and pull these things apart. Literally, I want to see this because I just cannot comprehend.
Well, that's a fair question.
You know, and it would be so much smaller than a drop of water, I know, but I mean, even smaller than a drop of water, and these bonds you're talking about, these tiny, tiny little things, I mean, I cannot comprehend that. I understand what you're saying. I get what you're saying.
Yeah.
But in real life, in real terms, I mean, I don't know. It's great. Like, I don't know. I get what you were doing with, you know, adding water to a certain chemical and, like, gas would be created because of it. Like, I get that, but when it comes to...
Wow.
Pulling things apart, I know what that is.
Wow. I'm sorry.
Are you sure?
Yeah. I just went, like, a long exposure on, this is the Dumbbell Nebula, folks, yeah. And, I just went 30 seconds at 25,600, and now you can see the... And I'm sorry, I don't mean to take away from what you were saying before, Amanda. Because you were making a good comment about chemicals and the bonds and so forth to get certain things. But it just takes a little basic understanding to understand how atoms can recombine to cause things like what we're seeing here. You know, that nebula, as Daryl said before, you're looking at, this is a planetary nebula, so-called because when Charles Messier was hunting for comets, which was his primary occupation, he found these things out there and said, "Oh, that's not to be mistaken as a comet. We'll call that a planetary nebula." You know, because it looks kind of like a planet, a dim planet. Back then, they didn't know anything more about the planets to know that they wouldn't ever be this dim. But anyway. This is the dumbbell, and it's Messier 27, and we're seeing the result of the recombination of oxygen that's been doubly ionized back into the center of this nebula, ionized by the radiation from the white dwarf that's right there in the middle that you can actually see. I think we can zoom in on this white dwarf here. Yeah, you see the white dwarf right there in the middle. And you also see the kind of the graininess of the image. I can get rid of that graininess in the processing later. But this is the kind of thing that it just blows your mind, you know, when you see this, you know. In fact, there might be a little thing I can try while I've got you all here on the line with me. I want to see if maybe I can do something a little dynamic. So let's go and just let me try something while I got you here. Excuse me. That thing that I was trying was not to sneeze. That I could do most efficiently. Thank you. I want to do something else. So let me try something, guys. Trying to remember how to do this. Okay, try this. I'm gonna try and add a filter. Okay. Now, that showed a little better. See what I did there?
I do.
I think you guys can see what I did, right? I'm assuming they can see that.
Yeah, I think they'll see the change. I don't think they'll see OBS though, which is good.
They won't see the what?
OBS.
Oh no, that doesn't matter. So you guys actually can see now how I did make a change to it, right? I can actually modify it even more differently here to kind of, okay, kind of like the Hubble would look at it. So it's more like the Hubble might see it.
Yeah, they're seeing all the changes on YouTube.
Good. Yeah, so this is kind of like how the Hubble might see it, and or like this, and we can bring it back. And this is very helpful, because then this is another way. When you come down here like this, you can see the modeling in the center, and you can see different some of the different elements. This is one of the new things I've been experimenting with, just so you guys know. You can see how there's different elements that show up right about here. If you notice, you can see much more detail in that what used to be the very bright blue. I'm kind of reducing the blue a little bit. And now if we bring it back to what it was, this is kind of what it was, see? But if you take out some of the blue, you can see the detail behind the blue. Alright, so these are more of the hydrogen alpha locations, the areas of hydrogen inside the Dumbbell Nebula that have this other convolution hiding inside there. I think that's pretty cool. I'm hoping that that actually is something that makes sense to you and that you can see, and I like it. So now let's bring that back. We can also. I
still like the original colors we see the best.
Oh, I agree with that. I agree with that. Okay, but let's.
They're pretty cool. They're pretty psychedelic, but.
Yeah, but it's meant to show detail, though. See?
Oh, I know. But...
So if we just come back to what it was, okay, then this is about. Let's see, right here. No, about right. Okay, so right about there is what it is naturally. But I also, it used to look like this. This is what it looked like when we came in, by the way. Okay. And what I did was I was able to knock out some of the brightness of the background, increase the contrast of what we're seeing. Okay, like this. And then if we drop the brightness a little bit, it starts to look better right off the bat. And then by messing with the saturation, we can drop that down just a little. See, we can go right to black and white, okay, or we can go up even way higher, which is crazy bad, you know, which you might not think is bad, but it's just terrible.
Oh, it's totally blown out, but it was vibrant and it's pretty.
Yeah, vibrant and pretty, but that's about it. Yeah. But this thing here is very important, though. When you can drop this out, you can actually see the detail inside that nebula. Okay, a lot of modeling in the center. Very, very interesting. And now you can see more of the spherical nature of it, by the way. Okay, the oxygen part that we see there, this oxygen is actually something that tends to give it an hourglass shape. And that hourglass shape is something that we're not actually used to seeing any other way, but if you knock this down, you will see that you don't have that that hourglass shape alone. There's a spherical nature to this nebula, and that's what we see here. So there's the Dumbbell Nebula as seen, you know, here by this object. I'm sorry, by with this color correction. That we did, and I did want to make sure that we bring this back to what it was. I'll go back to defaults there. Okay, so you can see now what we're looking at. Okay, and now I think
it's so pale and gross.
It does, because you're used to now seeing it better. You know, when I made it look nice and good, you saw how pretty it looked. And that's okay. That's good. I'm happy for that. I want that to be the case. You know, so I will take this. I'll take this object and move it over here. I guess I'm gonna have to kind of just do it like this. Actually, you know what? Will this be still here? Okay, I can maybe do this and this. Oh, it doesn't let me do it.
Don't mind the mumbling, folks.
Yeah, I don't mind my mumbling. I'm trying to just get something. Trying to get something to happen at the same time.
He's working with the settings on OBS to make these color corrections.
Yeah, you can do that.
So he has a few screens open, and yeah.
Yes.
But it's all for you guys.
It is. It is. Trying to get this nice, and then the brightness is still good too. I can dump the brightness, but see, this is what you're seeing here. This is how it looks in a small telescope, and people say, "Oh, look, I see it," you know, but really, it's really got all this detail in it, which is kind of cool. And then with a nice lens, you can get this contrast with it, but you'll never see the color to your eye. All right, it's always gonna look like this. Okay, at most. But this is actually a good. This is actually a good thing. If I show you this, okay, this is what it looks like in our telescope here. Okay, but now if we were to show you what it looks like only to your eye in a telescope, this telescope, it would probably look like this to your eye in the telescope at its brightest. Okay. All right. What you don't get is you don't get all this, and you won't certainly get this. This only comes from seeing the nebula with the camera that can see it very fast. You just don't get that. See? So that's kind of cool. I like this, and we will keep doing this. We will keep doing this for other objects too. All right. Namely, the next object we're going to go check out, which I think some of you might automatically want to see.
And remember, I still have...
You have one of your own.
I do.
Yeah, what's yours?
If it's possible.
What's your request?
Something in Cancer. It's my mom's birthday today.
Oh, I wish I could, but Cancer has set. I'm sorry.
Figures.
Well, you know. Yeah, Cancer is right to the left of Orion, basically.
Okay. Well, I mean, I knew we wouldn't be able to see the whole constellation because it's so big, but maybe an asterism or something.
Yeah, no, it's not going to happen, unfortunately. Alright, let's go to another object. Alright. Let's go. I'm going to go into 4K mode here just to make sure we've acquired it, or that we're acquiring it. And we are. There we go. Okay. And people already know what we're looking at, I'm sure.
I don't know why you always pair these two together. And when you hinted that people might want to see this next, I already knew where you were going. I swear, I said I
believe you. I believe you, but think about why that is.
Because they're both planetary nebula?
That's correct, and besides, they're very close to each other in the sky. And we're going to do 30 seconds at this 25,600 ISO again. And the reason we're going to do that is because it's straight up. It's right overhead. So I think that we're going to see the best it can be. So we're going to see what it looks like. Hey, David Schmidt, how's it going? Nice to see you here. Ooh,
he's in Thailand. Isn't that where those kids are trapped in the cave?
Yeah.
How close are you to that scene, David?
Well, I'm sure they're all rooting for these poor kids.
Well, not just Thailand, obviously, but...
Yeah.
I don't know, I think of it as kind of like a small community kind of based country, but I don't know much about Thailand, obviously. I just think, you know, never mind.
No, I was listening to what you were saying.
Oh, no, I know. I just trailed off and, again, don't want to bring the show down, so...
You did just trail off.
I did.
And you didn't have to. This exposure might be ruined because I bumped the camera a little bit. That was a low-flying airplane. It wasn't an airplane. Okay, let's see here. Okay, that's actually way too high an exposure for this. So I'm going to go down to 10,000 for 15 seconds, starting now. Okay, yes, it's the Ring Nebula, folks. M57, Messier 57, the wonderful Ring Nebula that is a fixture in the night sky. There it is. Let's go see it. Let's see how much we can see of it here. Alright, this is it. Go back and get here. Alright, now the first thing I'm going to do, you can see the central star, but the first thing I'm going to do is I'm going to come back in to this guy and bring up the colors a little bit and drop the contrast a little to more of what it was. And if I drop the saturation a little, you can sometimes see more data. And then the hue shift, let's do that and see what we get. Ooh, that's cool looking. And you can see some of those changes we're seeing are artifacts of the color splotching that we get. But I think that's pretty neat. Yeah, David, I thought they were actually trying to pump that cave out, and as far as I can tell, these kids are kind of weak, so they probably can't get out. So most likely they're going to have to stay there for several weeks and just be treated on site by SEALs and other potential paramedics that can actually venture in the couple miles that they're in this cave. There's a lot of underwater passages right now. Man, and then they have to squeeze through, yeah.
Yeah, but I heard they're running out of oxygen. I mean, what can be done? Because I don't think there's any vegetation or anything growing in those caves to be producing more.
It'd be too slow to produce anyway. I mean, the chamber is, if the chamber is truly locked in, if it's not a very big chamber, then there will be a lack of oxygen. But what they can do is they can run a hose all the way in, and they will probably come up with several miles of hose, and they will pump in air from the outside. That's actually one way in which they can kind of counteract the pressure. They can overpressure that water and push it down like a ballast tank on a submarine. I don't know. I mean, first of all, and David just hit on it. I was about to say that. They had a teacher with them. Why would this guy even take the risk? And why would the soccer team decide to go spelunking 2 miles in a cave system? It had to be a very popular, very ordinary cave, I don't know. I don't know. And so I'm guessing that Dave's sort of in the middle of it, and he's very sensitive to this because these are kids that are like probably the age of the kids he teaches, for crying out loud, So it makes me crazy. I was actually trying to figure out if there was a way for me to go over there and help them, to be honest with you. I thought, gee, could I generate something? Could I build a little drone system to help go through the water because I did submarines for this stuff like a long time ago. But they've already got more than enough good heads there. They don't need any additional people like getting in the way. But I'll tell you, man, this is just not a. It's definitely not a. Definitely not a pretty thing. I've just like really been bothered by it. But I don't know. Anyway, I'm going to take another picture here, and I'm going to go down from 15 seconds to 8 seconds at 10,000 of the Ring Nebula.
Oh, Daryl, I hope that's cool. I hope that's true. I said that Elon Musk is building a child-sized submarine for them. That would be so cool.
He's building a what?
A child-sized submarine.
Well, that's the other thing. But the problem with that, though, unfortunately, is that they've got to go through passageways that are very, very close to being their own body size. So, they have to squeeze through passages. So a submarine would never get through there. So I don't think that is a practical possibility. A practical possibility, though, is, and it might be impractical if the rock is sharp. The astronauts on the space shuttle, there's an emergency escape that the astronauts on the space shuttle had, and it was like a little ball. They would go inside the ball, seal themselves in with a supply of oxygen, and then they'd have like a 1 atmosphere in there, and then the ball with an oxygen supply could be transported from one shuttle to the rescue shuttle. So the astronauts could go in their street clothes from one shuttle to the other and be rescued. It's never been tried, but if there was some type of bodysuit type thing that they could wear, even if it was just a helmet for the head that seals to them, or straps down. But I think they have to go horizontal for part of this, and this means designing something new for this specific thing. But man, I don't know what it's going to be like. I don't know what this will be. I'm thinking it's going to be a good outcome, but I think it's going to just be a very long and laborious outcome. It is. I just don't think they're not going to. I don't think anyone's going to die from this. I think that they were found in time.
Someone already has.
Well, I know, but that was not the. That was no one with them, right? That was a Navy SEAL that died. He actually ran out of oxygen.
So what chance do these weak kids have?
Well, the Navy SEAL just, in the excitement or whatever, he made a mistake, unfortunately. That obviously changed everything. Yeah, here's the Ring Nebula. This is really pretty. It's 1,400 light years away, and with the dynamic processing we can do, we can actually see a little more detail. And you have something called the gamma. See this? See how it's looking? I mean, yes, it's increasing the grain around it, but you can actually see more detail. And then what you do in addition is you take the contrast and sharpen it down. Not clearly too much, but if you can just adjust between these parameters, you can see how certain things, and look at that. On the left side of the Ring Nebula, you actually see now one of the characteristic little lanes, a dark lane that's kind of moves around in there, and that's actually in the nebula itself. You can actually see that, and it's not that visible when you look at it just like normal. When it's just like in the default settings, it looks like this. And let's see, if it's this, it kind of looks like this. You don't see it, so you have to play with the settings to actually be able to see and tease out more detail. I just think it's cool, but that's just me. Just me. What do I know?
I think it's cool too.
What do I know? Hey, what can I tell you? Now, I'm going to close the night with one other beautiful object that many of you might want to see. And of course, that'll lead to wanting to see yet more objects of this particular nature, and I totally agree with it. I agree with you. You know, yes, we have Saturn. Yes, we have Jupiter. Yes, we have, we had Venus at sunset. But because it's such a beautiful dark night, I would like to take advantage of this. Okay, so we got this. And now I've got to be up for this because I've got to make sure that I got to make sure that my before I go anywhere, I've got to make sure that I retract the dew cap because it may be a little too. There we go. Okay, it might be a little too close to the dome if I don't do this. Okay, so now let us to go this next place now. Okay. Oh yeah. Wow, this is beautiful. It's actually, oh my God. Oh, I gotta tell you guys. I mean, I see the Cygnus Milky Way going overhead. I see the Sagittarius star cloud. I see Cygnus with details that are just beautiful and beyond. And I'm absolutely loving this. And now I'm going to do this. I'm going to take us to another place. Let's go here first. I'm going to just do this. I'm going to check this out. That's what I wanted to see. Okay, and I'm going to move us down just a little bit. There we go. Okay. And now we go, let's see, let's go up to 20,000 ISO. And we'll do 25 seconds at 20,000 right here. Right? Here we go. And it's off. And you're going to see now, this is, it's a welcome to summer stream now because the summer sky is directly overhead. It's beautiful. We have Milky Way everywhere. It's a spectacularly clear night. I'm very cold because I'm only wearing a light sweatshirt, and I probably should have worn a much heavier sweatshirt. Oh, jeez, holy cow! Wow! Look at this!
You're funny.
Oh, man! Wow! Oh, I'm just stunned. Oh, this is the Eagle Nebula. Oh my gosh, look at this. Look at that. Oh my gosh, oh. Wow. Look at the details. Look at the details. Let's play with this now so we can play with the gamma, which is oh, look at this. Oh, look at that, folks. Look at this. Oh, wow. I mean, how do you... Oh, this is just beautiful. The Eagle Nebula, guys. Here it is, and it is just beautiful. Look at
See,
that.
I always think it's a person, like, holding, like, their hands together like they're praying. I always think of this more as, like, an angel.
Yeah, it looks like that. It can look like that. And then with the angel's head being kind of like an oblong-y thing.
Yeah,
and,
see, like, I recognized it when I saw it, but I would not have known it to be the eagle.
Oh, you can't
But I
miss
always
it.
think of it as an angel, so I'll have to remember the angel is an eagle.
Wow. I'm trying to,
What city are you in? Is it called Confusion?
My city?
Yeah.
No, it's Terryville.
Oh.
You mean what state am I in? Confusion?
No.
Yes.
No.
Okay.
Oh, no.
Alright.
Sorry, state. I was thinking Connecticut, not state of being. Yeah.
The state of confusion, right?
Yes.
Look at this. This is... Oh. Wow. The eagle is just stunning me. You know what? Time for more clothes and an extended stay out here. I'm telling you, I gotta... Look at how beautiful that is. I'm actually going to go to 30 seconds at 20,000. Let me go to 25,000. I'll push my luck. Alright, and then I'll just try and deal with it. Oh, okay. Okay, here we go. 30 seconds at 25,600 ISO. I couldn't believe that came up as beautiful as it did. I was just stunned. Wow. Oh, my gosh. That's what you get, you know. Sometimes when the sky is just beautiful, the transparency is really, really good tonight, as it's called, and the seeing is very good. So, it's just beautiful. It's just so beautiful. Oh, I mean, it's taking my breath away. It really is. It's taking my breath away. Look at this. That's a 30-second shot, by the way, folks. I mean, that's not bad at all for, you know, you got to remember also this is the location, and these are the pillars of creation you're seeing in the middle there. Okay, the upper one, it's the whole sets of pillars are just to the left of center, and the upper one has a bright part on top of it, and just below it is another one, and below that is yet another one. And the Hubble Space Telescope took a photo of them that was called the Pillars of Creation, and they are gorgeous. They are gorgeous. That's the Eagle Nebula. Wow. Jeez. Okay, well, I'm coming back to that. But next is one more. See, now I thought I was going to end with just one thing. It's like, yeah, I don't think so. Just can't end with this. Okay. And let's go to this next one. And it's going to take us down a little bit. Okay, and we're going through the whole summer Milky Way, guys. What can I tell you? And why not, right? Why not? Alright, let's see what we got here. Yep, it's there. Wow. Alright, so let's go down to 25,600 again. Right there. And let's do 25 seconds at 25,600. And off we go into the wild frozen yonder. I don't know what I'm gonna do, because this is just so beautiful tonight. Absolutely stunning. It's like I can't even. Wow! I mean, it's an instant masterpiece. Just like, look at this. This is the Omega Nebula, folks. This is just a beautiful. We can adjust the gamma a little bit, and look at that. It's almost as if we're image processing them in the camera now, but I'm using the broadcast software to help us with that. That's the Omega Nebula. Wow. Oh, absolutely stunning. Absolutely stunning. I mean, just you can't beat this. You know? You cannot beat this. And of course, you know I'm going to have to try something else now, don't you?
Of course.
Yeah. So we're going to do that now. I'm going to move a little bit south, and there we go. Yes, that's right. That's right. Keep it up. Okay, let's just see where this is going right now. That should be good. Okay. Oh boy, I think I'm gonna be just having a conniption here when I see this, how this is gonna look too. 25 seconds at 25,600 here. Oh my. I gotta prepare myself for this because I think this is gonna be really beautiful as well. I apologize ahead of time if I blurt out something that sounds really...
Uh-oh. Are we going 18 plus?
Come
on, you did so well this whole time.
I am not going to say anything bad because all this makes me do is... Oh, look at that! Look at that! Holy boop! Oh, that is just so boop and beautiful. Wow. Look at this. This is the Lagoon Nebula. I've never seen it with this much detail. I've never, ever, ever seen it with this much detail. Holy Cisco. Wow. Unbelievable. This is just... yeehaw. Wow.
It kind of looks like a bit of a smiley face, but it's not the Pac-Man Nebula, is it?
No, this is the Lagoon. This is the Lagoon. Which reminds me, if we get more nights like this, holy cow, I mean, if we could... Oh, I'm gonna, after I cut the stream tonight, I'm gonna come back out. I'm probably gonna be out here much of the night, doing photography. Look at the details. Look at the detail in this nebula. It's stunning. God, this is stunning. I'm sorry. I don't mean to. I don't mean to be so, I don't know, crazy. But I can't help it. I cannot help it. It's just really, really pretty. Really pretty. I can get rid of all the noise too that you see on the screen. All that kind of fuzzy noise that comes from the. Oh, this is so beautiful. I can get rid of all that. Well, geez. Okay. Well, while I'm here, why don't I try another landmark object that you just gotta check out too, since you're here. Let's go take a look at this. I don't know if you can even see this. Yeah, not that, but... Oh yeah, here we go. That's what I want to see. Okay, just a minute, guys. I'm getting there. Okay. And now we're going to go to the next one. It's right nearby. Let me just validate that it's there. Okay. There it is. Wow. Okay, well, let's take a picture, shall we? Well, yes, we shall.
I think it's only fitting.
I think it's only crazily beautiful. Okay, jeez, let's do this now. Okay, 25 seconds at 25,600 once again. I can't believe the night, guys. It's just incredible. Stunning. Magnificent. It all started with the veil. When I saw the detail in the veil, I said, wow, this looks kind of interesting. And then I saw more. And I was like, whoa. Haha. Wow. Welcome to the Trifid Nebula. Look at this. Holy cow. You know, look at, I mean, this is what it's all about. I'm telling you, man, this is what it's all about. You just gotta love this, man, when you just do this kind of stuff. Look at how we can isolate stuff here. I like doing it dynamically, by the way. This is kind of cool. Bam, instant process. You know, I mean, that's just beautiful. That's the Trifid Nebula.
As much as I love the blues, the reds and purples, like this and Orion, and there was another one that was like really dark, vivid.
Without a doubt. Without a doubt.
They're
you know,
gorgeous.
You're right. Wow. So this is.
And I find
just
like the blacker
crazy.
the background, the more the color pops, and whether it's natural or a little bit manipulated. Oh, it's just like those are the kind of pictures you'd want in your house.
Yeah, but see this. What I'm gonna do is I'm gonna I'll be ending the stream here shortly, and then I'm gonna go get dressed.
Didn't you say that an hour ago?
Yeah. What object did you want to see? Oh yes, Cancer.
Oh, we
Cancer.
can't see Cancer. Yeah.
All right. Wow. I'm just like, this is just so like wowie. It's like yowza. I'm amazed, and there's a little bit of moisture on the outside of the dome, so we are getting some dew. But I gotta. Oh man, this is just beautiful. Oh, this is so beautiful. I really don't know what to say about this, guys. This is one of the nicest nights we've had. You know? Wow, this is just so cool. This is great. Makes me want to look for things that I know are much more difficult to see. Yes, it does. Yeah, it does. Before we do that, I think that
What are you thinking?
yeah, I'll tell you what I'm thinking. Let's just go see what a
1 more hour, yay!
no. Let's just go see what a global dust storm looks like, shall we?
Oh, I think I know where we're going.
Yeah.
And eventually you can check out SkyTour News on DannyFan1. So
Yeah.
subscribe and hit the bell if you'd like.
Yeah. I mean, with
And
this,
if you guys want a little teaser that has nothing to do with this, Tana, new channel coming. Well, for everybody, obviously.
that's right. It's not just Tana.
No, but I think she might get a kick out of one of the series. There's going to be multiple series on this new channel, and the one I'm heading off, I have a feeling she'll like.
I'll bet you're right.
I hope everyone likes the entire channel, but
I
we'll
go
see.
down to 50, and let's try this just to see. Alright, it's pretty. That's a little bit messed up, but let me try and focus this a little better.
Oh, good news from Fantasy. The kids in Thailand, the kids are on their way out as we speak. Divers are starting the mission to get them out.
Oh, fantastic.
If I could do a shameless plug that really has nothing to do with anything, check out Agenda Free TV here on YouTube. Agenda Free TV. I'll put the link up in a second.
Okay.
Steve Lookner is always on top of all the breaking news, and he's been covering Thailand kids rescue. So,
All right.
so thank you, Fantasy. That is wonderful. Not yet, but the divers are heading in to get them. Okay, so I'm guessing Agenda Free TV is going to cover all of that, and Steve Looker is so funny.
All right, cool.
Sorry, thank you.
Well, we can't even see any detail on the surface. And typically, we can see the polar caps, but Mars has it's actually quite bright. And the reason it's quite bright, of course, is because of that dust in the atmosphere is making it be a bland, orangey, reflective ball. So that's kind of how it looks right now. But I just want to...
as we leave, he is already covering it.
Alright, good.
So...
Well, folks, I hope you enjoyed the stream tonight, and...
Sorry, I'm sorry, I didn't mean to...
No, it's okay. But I'm gonna close down now. I am getting cold. I'm gonna have to go in and get a sweatshirt, and then I'm gonna come out and do some more photos for all of you. I just wanted to let you know that I really appreciate you guys, and Amanda does too, I know that. And I also want to thank you specifically for coming tonight, Amanda, because I know you have plenty of other things that you're worried about, and for you to come here tonight is actually...
distraction. This is exactly what I needed. I would just be pacing around lost all night, so thank you for having me on. And,
absolutely. No doubt.
Broken voices. And yeah, I may not be around tomorrow for SkyTour News, but...
You mean for SkyTour Radio?
SkyTour Radio, that's exactly what I mean.
Okay, no worries.
We are a good team.
We are. We'll make it happen, and I'm glad you announced that you may not be here, which is fine. And I will, I'll check back with all of you a little later tonight, possibly by doing some uploads of some really cool stuff. But I got some processing to do. I'm going to process a lot of these when I'm done. So that'll be kind of cool. Anyway, I hope that you guys have enjoyed this time here with us. And I'm hoping that you'll come back again. And I hope that you would just like the enthusiasm of I just was like ebullient with enthusiasm. It was just incredible.
They love it. I don't know if you saw the comments going by, but that's maybe one of the highlights of this channel is you acting like a kid because you are just so passionate, and it's infectious, and it really does spread throughout the community, and that's what keeps people coming back.
Well, you know what? I want to thank all you guys for coming, and thank you, Amanda, for joining me as usual. And you can look for Amanda and I on SkyTour Radio on kgraradio.com on Sunday nights at 9 p.m. Eastern Time. And we'll bring you more astronomy and more love of the universe to all of you. We'll talk about things, how they formed. We'll talk about mysteries of the universe. And it's all for you, our wonderful followers and subscribers. So I'll see you again next time.